Today we would like to share some information ongoing networking activities from the national scales, regional scale, and global scales. And I believe that the speakers will provide us or share us the experience, how they have been establishing their communities of practices by having the collaborative observations or designing the new observation schemes or capacity development. How do we mobilize the data, the existing data, or how do we integrate the newly obtained data, and how do we generate those data into the indicators for sharing the, to have the collective efforts at the national, regional, and global scales. And I believe Petri is now ready.
No, that's perfect. Yeah. Good. Okay, thanks, and good morning, everybody. Nice to see some people here still. It has been a great week, and Friday is always the hard day to keep audience interested, but hopefully you will enjoy with us with these different biodiversity monitoring discussions today. So I would like to start with this picture, which you saw already during the kickoff. So it's from the recent GBIOS paper led by Andy Gonzalez and numerous GeoBond colleagues. And I think the session today is very much focusing also for this picture, because we are really going to go through the different bonds and national, regional, thematic biodiversity monitoring networks. What are the possibilities for them to provide information on biodiversity ecosystems for decision making and harmonized different indicators and use cases. So this is kind of like a framework for discussions today. We are working with monitoring schemes, but we are also focusing for some transversal topics like EBV protocols, different tools, and so on. And if you go to the this paper, you will find also there's some supplementary material where we actually have been going through from our GeoBond colleagues what kind of biodiversity observation networks there are in place already. Oh, it's so small, I should need the binoculars to read this there, but anyway, there are like different regional bonds recognized. We have an Arctic bond, where we have a presentation today. There's Asia-Pacific bond, what Hiroyuki is representing. Then we have a Europa bond, which had a separate session on Wednesday. Quite many talks from that. And European Biodiversity Partnership, which I'm representing soon. Then there's SASCAL observational network from the Southern Africa. And then we have numerous different national approaches. Australia, China bond, Sino bond, another one from China, Colombia, Finland, French bond, Japan bond, again, Nepal, New Zealand, Taiwan, South Africa, Switzerland, as examples of different national networks. So you will get that information from the appendices of that article as well. And then we have these thematic bonds, which we have some presentations today also during this day. So marine bond, freshwater bond, soil bond, omic bond, which has got a great audience and good sessions during this week. Then coral reefs and invasive alien species as examples of the different thematic bonds. So all this will be covered during today. And the morning talks are a little bit more for terrestrial. Then we have a second session which is a little bit more aquatic, but also Arctic is there. And then we have a last one which has a lot of these transversal activities also included in this one. Maybe I give floor back to Hiroyuki, so you can give a quick overview of this topic.
Thanks. You can stay there. So this is just a copy from the our agenda that already shared on our program. So now we just recap the part we want to discuss today. That anyway, we will have some many information, new activities, existing activities, or the upcoming concepts today from the world today. Then we will try to think what would be the power of the networks, functions of the networks, and how do we engage with the many scientists, stakeholders by having the networks as the hub of these activities. So next slide, please. So sorry for the tiny letters. Maybe if we think about the networks, we may have many functions that the networks could provide us. For example, we think about the networks of the scientists or stakeholders, players, or the network of the networks, like a geobond is a networks of many kinds of bonds. Then what would be the about network for observations? We will have domains and infrastructures. Then we would have essential biodiversity variables as a common language for the collective activities through the networks. The capacity development would be also the important function of the networks in many kinds of capacity development. Then finally, engagement. The networks could be a hub of the networking, the people, stakeholders, and many kinds of activities in the world. So, and also, very importantly, the next generations, because we should have a very continuous long-term efforts to address the biodiversity issues. So I'm not sure whether we have the time for the overall discussion. I would like to just propose shared questions like shown in the right-hand side. So what does networking enable us? How do we mobilize the networks? What are the challenges in networks or networking? And finally, how do network and EBV design help GBIOS to be developed? So through these presentations today, let us try to continue about the networks and how can we to be a player for networkings or mobilization of the network for the collective efforts of the biodiversity observations and deliver to the society. Thanks.
Thanks, Hiroyuki. And this is just a reminder of the agenda today. So we have first 1.5 hour session, 4 talks. Then we have coffee break. Hiroyuki is chairing the first one. Then the second part after the coffee break until 1 o'clock. That's chaired by Guillaume. And then we have a lunch break, and we come back here at 2 o'clock for this final session, which I'll be chairing. Okay. But then I go to my first talk. It's about this Biodiversity Plus European Biodiversity Partnership, which I gave a short introduction already on Wednesday, if somebody was in that session. But this is now a little bit different viewpoint, going a little bit deeper of what we have been doing during the first 2 years of this active partnership in Europe. So the basic aim is to come together with different biodiversity monitoring, steering and funding organizations, ministries of environment, environmental protection agencies, from representing really national or subnational viewpoints of monitoring and bringing that kind of harmonized approach then for the biodiversity monitoring schemes to pile up information for the Europapon and the upper scale assessments where it's needed. This is short introduction. This is a partnership. It covers both research funding, but also concrete biodiversity monitoring activities. We have 80 partner organizations from 40 countries, also some outside of Europe as associated partners. And half of the partners are representing those ministries of environment, environmental protection agencies, which we think are really crucial players when you set up a long-term coordinated biodiversity monitoring across the different scales and the places. On top of that, we have research funding agencies which are putting together money and funding research, and there was a last call about the biodiversity monitoring topics. Over 30 projects get funded, and they will start next year providing interesting topics for the biodiversity monitoring across the different topics. We have quite significant funding, this both coming from the in-kind, from the ministries, what they are using for biodiversity monitoring, but on top of that, European Commission is giving 30% to this collected lump sum, which could be then used as a leverage to develop really some new harmonized monitoring schemes. And 1/3 of the whole budget is going for this biodiversity monitoring activities during the 7 years. So we have now worked 2 years, and we have still 5 more years ahead until end of 2028, which hopefully is then has significantly changed the landscape into Europe for this biodiversity monitoring. This is just a reminder also of these other topics. So biodiversity monitoring is one of the work packages there, which is having different elements from priority setting, harmonization, novel technologies, use of biodiversity data. And then we have a concept of pilots, and the ultimate aim is to develop a network of the national, subnational biodiversity monitoring schemes across Europe. And there will be colleagues Matthew and Guillaume tell a little bit more about this harmonization and priorities and EBVs, what relates to that work also. So there are a lot of topics what we are focusing, but we are guiding and prioritizing aspects of monitoring schemes, providing new resources for monitoring, supporting capacity building, and then engaging different operators. We are working close collaboration with Europapon, European Environment Agency, GBIF, and then Joint Research Center of the European Commission. What we did when we started this initiative, this is really new initiative, and it's new for all the partners also how we work together. There has been quite some time spent for trying to understand what we are doing, what we are aiming to do, what are our priorities and ways of collaboration. But now we are up and running, and everything is going quite nicely and smoothly again ahead at the moment. But what we did in the beginning we were really spending time interviewing all our partners, 23 countries at that point, so that there was a small group from Biodiversa and then the national representatives from the ministries and different key monitoring networks coming together. And for every country, we had the same kind of survey, and then we asked similar kind of questions, discussed similar topics. We wanted to get better understanding what is the current state of biodiversity monitoring in a particular country or sub-region, including monitoring networks, data management, and budgets used for biodiversity monitoring. Then we also asked the understanding of the EBVs, if they were aware of the whole concept and how they reacted for that, and they were not often aware, but they were quite interested in that opportunity. And then we also asked expectations towards Biodiversa Plus collaboration for the coming 7 years. And the surveys were done during the spring 22. And these results are findable from two publications, which you can find from the Biodiversa web pages. So mapping of the national and subnational organizations that fund and steer biodiversity monitoring schemes, and then so-called synthesis report, which comes together with all these different tasks and gives like a landscape of the biodiversity monitoring schemes in Europe, including colleagues from the GBIF and Europapon providing their views how we could work together with national level, European level, GBIF, and key other institutes. There were some key messages, quite obviously possible to get out from these interviews. So first, many partners highlighted that there's definitely lack of coordination in many countries. There's lack of comparable biodiversity monitoring data and schemes, lack of resources for biodiversity monitoring, and quite often it was a reason to be because of the project-based funding. So some years you might get a good project and good monitoring, but then it finally stops when the project is over and there's not this kind of really support for the long-term monitoring establishment. And then data interoperability was mentioned also as a challenge. It's difficult to organize with many data providers and data users. So these are like the key topics where we would like to focus and provide some solutions and co-design how we could get better systems, filling the gaps what these topics are covering. Then there was some special need for harmonization strategies for various monitoring schemes and some differences. What comes, for example, in situ monitoring schemes, they are quite often based on volunteer contributions, so how to get this number of volunteers involved and how to compensate their time and resources. Then habitat ecosystem process monitoring was also mentioned. That's quite often highlighted the challenge of integration different data types, so how to integrate remote sensing, intensive in situ measurements, and different models for meaningful products for different users. And then special topic from the marine freshwater monitoring community came that their infrastructure is quite often expensive, so it really cannot be done without some ships and vehicles in many cases, and sensors. So it needs this kind of scientific support also from that point of view. Also, the governance models varied across the countries. So in many countries, it was Ministry of the Environment or Environmental Protection Agency who was in charge of coordinating and steering in theory, the biodiversity monitoring schemes, while coordination was still, in many cases, quite poorly organized. There were also some other ministries who were in charge of biodiversity monitoring related topics. And depending the countries, it might have been that terrestrial, freshwater, marine realms were under the same ministry, but in some cases there were different combinations that terrestrial and freshwater might have been under different ministries, which brought some problems for coordination and so on. We also asked what kind of role these national coordination entities across the countries have at the moment, and networking activities were highlighted. Centralizing of the results was also mentioned. Funding of monitoring was quite important in many cases. Coordinating raw data, reporting to EU directives, and then also monitoring on the ground was done by some organizations, as well as creating biodiversity indicators, which is also often duty of this kind of national organizations. What we asked about the budget, so roughly half of the respondents thought that there's not good information about the funding of the monitoring available at all, or just partially, which is of course quite alarming. We should be quite well aware that how we are spending our tax money for different monitoring schemes or whatever is the funding mechanism, while in some cases there were information available for either monitoring schemes or coordination or both of them. But that's the topic what definitely needs more attention in the future. Then we asked that how our partners would like to see the future in Europe. So should there be one European coordination hub or just national coordination? But it was quite obvious that there should be both. So national bonds are really the backbone, which are hands-on with the national networks and data and resources. But at the same time, it's very important that they are doing whatever they want to do. So in Europe, with 27 member states and even some maybe new member states coming, it's really a mess if everybody do whatever they want, which is the current situation more or less. So this kind of European coordination and directing is really needed, and EBVs are really providing a great framework for harmonizing these national efforts for monitoring. But then there was also a call for thematic collaboration networks, so there are good examples of bird monitoring or butterfly monitoring across Europe, so maybe something similar could be learned from these thematic monitoring schemes for different taxa, where volunteers are anyway actively contributing. We ended up this kind of sketch of how we would like to see the future landscape, so it's important that we provide support for establishing these national biodiversity monitoring coordination centers, national hubs as we call them. You could imagine that they are national bonds in that case. And at the same time, it's very important that there's this overarching European bond or European Biodiversity Monitoring Coordination Center, which gives the overall frame what kind of data is needed for upper scales. But at the same time, national authorities often emphasize that they have also other needs, like local customers. They need to support municipalities and land use planning and all kind of things where biodiversity data is more and more needed nowadays. So it cannot be only that there's monitoring scheme which fits for large European monitoring, but at the same time it's important that there's a meaningful monitoring data available for sustainable development of the regions and the local scale. That's just a topic of the report where this information is also available. So it includes this Biodiversity Partners viewpoints, but then Europabon viewpoints at that time, GBIF's role in this collaboration, and then European Environment Agency's views for the future design of European biodiversity monitoring governance. We wanted to continue a little bit from this interview, so we established so-called pilot. We have a framework of pilots, which is really like a concrete way collaborate between these member countries. We wanted to establish this kind of module system where we have like a data modules, then results, essential biodiversity variables, and then use cases for different pilots. We wanted to demonstrate this kind of transnational collaboration with one species monitoring scheme and one habitat monitoring scheme, and then one transversal activity. And that was the first wave of the pilots, and we would like to go on with that and extend towards the other priorities. But in this governance pilot, we had 10 countries who wanted to spend a little bit more time and effort to think about how the national coordination models are working and what kind of data interoperability solutions there are in place in these 10 countries, and how the different standards, Darwin Core or ecological metadata language, are used in these 10 case countries. So these are the models, and that is expected to be finished by the end of this year, so there will be a report of these outcomes, which is then feeding in for this European design of national and European scale different hubs. And you will hear maybe a little bit more about this also later today. One part of that was that this governance pilot was really to engage with these national networks. So every 10 countries organize national seminars where they explain this bigger picture and European view and vision, and then also try to get a feedback from the national networks that how these monitoring schemes should be organized, and what kind of expectations there are, what kind of governance needs is really coming from the networks themselves, and how we could support that kind of design of the collaboration. And maybe that is something that will be then feed for the developments in the future. With this picture, just would like to highlight these other priorities where these different pilots are expected to provide information. So together with our partners, we started with 8 priorities where ministries of environment are more or less focusing their current project funding. That's basis of this in-kind money for this European partnership also. But at the moment, we wanted to extend because there were a lot of gaps, so we tried to increase the number of priorities to 12 state variable priorities and 1 transversal activities to really try to cover these other priorities what our partners also had in their mind. And these pilots hopefully will be then by the end of the 28 covering most of these priorities so that we can get experience from the different countries how this suggested biodiversity monitoring schemes are providing data which fits for the EBV scheme, and how much it then costs if you upscale it, and how much you need national money, how much you expect to get from the outside sources, and so on. So that's the work ongoing. And with the critical analysis of these pilots, we hopefully will be able then to give some suggestions for the future, what should be the long-term biodiversity monitoring harmonized schemes in the future across Europe, and what kind of methodologies could be used. And then that hopefully provides the data what Europe needs also to calculate some European scale EBVs in the future. So this is the current situation. The first wave of the pilots was covering these 3 topics, which I mentioned already: invasive alien species, soil biodiversity, and governance pilot. And now we are just about to start the second wave of the pilots covering reef rocky fish monitoring, acoustic automated monitoring of birds, bats, and nocturnal insects, and then mapping and monitoring of grasslands, wetland habitats. And quite many countries have been interested in joining these. And then we have this overarching task force focusing for this mapping of the national monitoring schemes through the different EBV dashboards, and providing also maybe then way forward how this national monitoring data could be harmonized through this kind of EBV protocols to the comparable products from national bonds up to the Europa bond. And I think Guillaume is going to tell a little bit maybe that in his presentation. So key findings, I think time is up. So we got overview of how biodiversity monitoring governance is organized across these 23 countries. We mapped the authorities which steer and fund, and they were recognized. We have now better understanding of the key networks in these countries. Also key monitoring networks and organizations were listed, and that varies really a lot. In some countries there were only few official institutes which provided most of the data, while in some other countries there were like tens of different networks where data was coming to be coordinated, for example, when reporting to the different international agreements. Then there was also focus on which dimensions of biodiversity are monitored, and that's varied a lot. In some countries this is really focusing for threatened species, while some other countries paid more attention for habitat mapping. We also highlighted the importance that the development of these national biodiversity monitoring coordination centers, and few countries had started that kind of work already, so maybe this is also possibility for the future bonds. It's kind of like an incubator of the future bonds also in that sense. Then these data infrastructures, they are really crucial for getting this data available and in open format. So there are definitely collaboration needed, and that's quite often technical. It's difficult for biologists, for example, so you really need IT expertise together to develop these systems. Then we need, of course, better understanding of the estimated budgets and figures, how much is used for biodiversity monitoring and how to spend it wisely and what kind of synergies there could be between different monitoring schemes. And project-based funding was seen as a really major problem for long-term monitoring schemes. And just final recommendation of these other publications, check the webpage, and happy to discuss more if you get interested in Biodiversity Plus. Thank you.
Thank you, Petteri. So we would have one quick question for you, and then later we will have more extra questions. So anyone? Yes, please. The microphone is coming.
Thank you so much. I was very interested in how you mapped out the network of biodiversity monitoring actors within each country. Well, maybe two questions. Is there like a network map available by each country listing out all the partners? And then also, can you maybe briefly compare like how those networks vary among countries? You said it varies a lot in terms of their size, but does it vary spatially across Europe with certain regions having more biodiversity monitoring actors, et cetera?
Yeah, you will find more information from this one report from the Biodiversity, how it was based on our informants of these different ministries and EPAs. But then at the same time, Europapon has paid a lot of effort for that. They have been trying to map this European landscape of different monitoring schemes. But they have been maybe more focused directly to the monitoring schemes itself, not via ministries of environment. So it might be that the landscape looks different if you ask from the Ministry of Environment or somebody working there, when you ask from the researchers who are really hands-on collecting data and making publications. So I think there are good parallel approaches and providing information for each other also. So I recommend to check both of them also if you are interested.
Thank you. Thank you very much, Petteri. So I believe you will have another presentation later, so then we can have more questions. Thank you. So again, good morning, everybody. This is Hiroyuki Muraoka from Japan and representing Asia Pacific Bonn. So I'd like to give you some ideas or some histories of AP Bonn that established in 2009, right after the GeoBond was established. So in Asia, Oceania or Asia Pacific region, we have varieties of the issues there. Of course, the environmental issues, including the rapid climate change, impacts of the extreme events, and also the increasing biodiversity loss, as already reported in the IPBES regional assessment reports. And as the external drivers for these changes, we have a kind of rapid increase of rapid growth of the economies, populations, and natural use of natural resources. So we have also we have the high biodiversity and ecosystem functions that are under the Asian monsoon climate. So we have many kinds of issues that we have to address by the integrative observations and also the delivering the data, knowledge, information, or the intelligence to the society to address these issues. Then Asia Pacific Bond, we established this in 2009, right after the GeoBond was established in 2008. This was called by when the GeoBond was established, the leadership called all the regions to try to connect the players, stakeholders in their own regions to have the regional bonds Then AP1 was established with three key missions. One is the promoting interdisciplinary research and problem-solving approach with filling the observation gaps and knowledge gaps. Then promoting data sharing and data accessibility by network of the observations on, of course, the scientists or the networks of many kinds of observations, which I will talk later, and delivering our information and knowledge to stakeholders and global platforms. So we had, just 2 years ago, we updated our AP-BOND's missions and strategy and published this paper. Then, in the last 13, 14 years, AP-BOND had been made a variety of collaborative research in the region. One is to establish many observation plots by cooperating with the International Long-Term Ecological Research Network in the region, because we need to detect the changes, not only the current status of the biodiversity, but we also wanted to detect the changes, temporary changes of the biodiversity, including the species, populations, and also the ecosystem structure and functions. Then, particularly in the Southeast Asia, we have new plant species to the science, and that is also the reason why we need a kind of in situ biodiversity investigations there. And for example, another case is in the ocean or coastal regions. Our colleagues made some mapping ecologically and biologically significant areas for the coastal and biodiversity. And for the freshwater, the Mekong River Basin is one of the hotspots in our region that under the pressure of economic growth, natural resource utilization, and climate change. Our colleagues also made a in situ field observation to monitor the fish by engaging with the local fisheries. Then they find it that fish biomass, species biodiversity are impacted by climate change and also the construction of hydropower dams. Then finally, as you see in the right top, our colleague also developed a three-dimensional digital database to share with not only the academia, but also with the local community to monitor the biodiversity. Then having these all research activities, we have been shared all these data and knowledge through the database and publication. In the last 13 years, we have published many books or contributed to the CBD technical report, IPBES regional assessment, and also shared the data through the data papers by cooperating with the Ecological Society of Japan. And also, all these data or the knowledge are available by online databases by the members and also the AP-BOND website. And in the last 3 years, we had a problem as well as in the global community. We had a limitation to see each other, but we managed to continue the communications through having almost a bi-monthly webinar series in the last 3 years by inviting many existing AP-BOND contributors to have their research presentations or new ideas for the collaborative research. And also this webinar could be a platform to engage the next generations, new members for the Asia Pacific Biodiversity Observations. And this webinar series will still continue in the next years, even if we can meet in person, because bi-monthly or monthly seminars would be a very good opportunity to meet each other, learn from each other, and discuss for the future. Then AP-BOND would have also, AP-BOND is a kind of hub of many kind of networks or community of practices. So now you can see the APMO as a central part of this diagram, and we have the very important partner APM bond, AP Marine Bond, that led by Masa Nakaoka, who will present his activities later. Then we have the national bonds like J bond, K bond, or Nepal bond. And more importantly, AP bond has been developed in the last 13 years with a tight linkage with the activities of Asia-Oceania Group on Earth Observation. You know, many of you know about the Group on Earth Observations. AOGO is a regional component of this global GEO, and then GEO is an intergovernmental organization. By having the AOGO as a partner of AP bond, we had an opportunity to, of course, communicate to network with scientists of biodiversity, network is a scientist from other disciplines like greenhouse gas monitoring or ocean physics or food production, and also the governments. So by having this scheme of the network of networks idea, we could engage or expand our networking activities to deliver our data knowledge to the society. And let me give you some ideas from our national bonds or communities. First, J bond. Japan bond was established in 2009, just a few months before the AP bond, because we wanted to, the Japanese scientists were motivated to establish this kind of network, because in 2008 or 2009, we can remember that the COP10 of the CBD in Nagoya Aichi was right ahead. So the community of the biodiversity scientists or ecological scientists in Japan was motivated to establish this biodiversity observation in Japan to try to contribute to this Aichi biodiversity target. Then we talked with the Ministry of Environment Japan to try to align this activity with the international cooperation mechanisms. Then we established the AP bond. Then just recently, Japan bond was re-established by seeing the very recent needs to this networking, including the engagement of citizen science, capacity development of the many citizens, including the school teachers, to how to monitor the biodiversity, how to collect their data, and how to mobilize the data and information at the national scales. And from the Thailand, I brought this data from the Professor Young Tristrat from Kasetsart University in Thailand, who is also one of the co-chairs working with me, that they have been doing the intensive biodiversity observation satellite data, and also the modeling analysis. Then they have the map of the biodiversity and the changes, and of course they made it this kind of tree atlas in the Thailand. Then they are now trying to develop a kind of feasibility study how the existing data and model or satellite data, this combined integrated data, could be used for evaluating the 30 by 30 goal. From Philippines, I mean ASEAN Center for Biodiversity. This, you know, this international intergovernmental organization for the biodiversity observation, and also clearing house mechanisms for the biodiversity observation, data sharing, and also the capacity development. They have the very intensive activities for the capacity development about the data mobilization and how to use the data or knowledge by the social stakeholders for the conservation of biodiversity and sustainability use of the natural resources. Nepal, ICHMOD is a very strong partner with the AP bond, and they have been doing a very intensive biodiversity ecosystem observation in Hindu Kush Himalaya region, as you may know. And Hindu Kush Himalaya is under the intensive impacts of the climate change as you might imagine. So they have been doing the monitoring, of course, the biodiversity status, like species monitoring, or the tree growth along the climate change, environmental changes along the gradient of the altitudinal gradients of the Himalayas. Then they have the data and knowledge platforms, and they are doing the capacity development to utilize this data and knowledge. Then, as I mentioned earlier, AP1 has a very tight linkage with Asia Oceania Global Group on Earth Observation, AOGO, or even the global geos. Then in the last 2 or 3 years, AP1 hosted a special session in the annual AOGO symposium that focusing on the biodiversity, climate change, and observations, and how do we connect these ideas with the societal needs, like including the TNFD. Then Petri was invited at one of these special sessions, and finally one of the outcomes was that we found that not the Earth observations, including the in-situ biodiversity observation, could be used for the next step will be the integration or analysis of the data, not only the biodiversity, but with also the climate change or other environmental changes. Then we produce the intelligence beyond the knowledge or information. Intelligence means how can we address the conservation needs or the sustainability of the natural resources. Then this information or intelligence could be used by the societal stakeholders. Then if the situations could be turned to better status, then the value chain from the observations to utilize the data and knowledge by the society could give a very good feedback to the observation needs. Then this kind of value change could, in the future, enable us to have a sustainable observation and utilization of the data for the society and also for this natural environment. And this would be almost one last slide from me. And just one quick idea how AP1 could contribute the concept of GBIOS. As we already know from the paper by Andy and other colleagues, GBIOS could be a concept of integrating the existing observations, including the many kind of hand manual observation by our scientists or the operational observation related to ecosystem structures, functions. As shown here, this is the concept from my own long-term ecological research site in Japan. And 30 years ago, we already installed the CO2 flux observation towers and many other ecological research infrastructures, including the canopy access towers and photosynthesis, soil respiration, and the in-situ remote sensing sensors like spectroradiometers and automated camera. By having this suite of the observation, then we can have the integrated knowledge how the environmental change impacts the ecosystem, components of the ecosystem structure and function, and then what would be happen at the for ecosystem functions under the climate change, and what would be the consequences with the biodiversity changes. Then maybe this kind of platform, research infrastructure or platform could be a part of the GBIOS. But to do so, we need much more networking with other observation networks, including the LTRs or the FluxNet. Then we have the interdisciplinary approach to address the growing needs. Then I think I'm running out of time. Then I'm not going to the detail, but in the last couple of years, the AP1 and other partner networks have been analyzing what would be the needs, challenges of the biodiversity observation, what would be needed for the engagement of the other stakeholders, and more importantly, how to engage or invite the next generation scientists or the facilitators to bridge this science and society. Then, thank you very much for your attention, and I look forward to have more cooperation with you all. Thank you very much. And I'm afraid that I already run out of the time. So thank you very much. Just one quick question. Yeah, thank you.
Thank you so much. It's kind of a big question, but how do you find the time and do you have a full-time coordinator of the network, or is all of the coordination and the work that you do to coordinate all these projects and communication, is there one person in charge of that, or is this all you are doing on top of your research time, or? Yeah.
Thanks for the very important and critical questions. Actually, AP-BON has been supported by the Ministry of Environment in Japan, a Biodiversity Center of Japan. But this is, they support our communication budget, like having the workshop, symposium, or webinars. But as you understand, we need a kind of communicators or the facilitators for the activities. So in the last 13, 14 years, the co-chairs of the AP-BON have been doing that, taking that role. For now, I'm doing that role. So in some time, of course, we are struggling to have the time, energy to do that, but this motivated person can help the community to work together and connected to be together. And by showing this activity to the all other participants to the network, then some people are getting know to that that kind of function are really important, and then this really community of practice could be a good engine for the expanding the networks and also the continuity of the networks. Thank you for your question. Thank you. So thank you very much. Then let's move on to the next speakers. So I would like to invite Maria Camila from Humboldt Institute, please.
Good morning, everyone. I'm just going to wait a second. Okay, there you are. So I'm here to present you Biotablero, and I'm going to present you the first part, and the other part is going to be with my colleague, Victor. So we're both here today. Biotablero, if you, okay. There. So Biotablero, it's a platform, a web page that we implemented in Colombia, so we can show indicators, so we can show special information and different kinds of information, of Colombian information for stakeholders, for decision-making purposes. So the idea began with giving this information in a simple way, in a didactic way, and for people to use this information, like in reality. So the Biotablero team, it's a really big team that includes engineers, includes ecologists, biologists, but it also includes the users, the stakeholders, academic world. So it's not just us thinking about how we want to show everything, it's us thinking with the possible users how they want to see this information. We develop Biotablero in different modules. We have implemented 5 of them, but all of them are a work in progress in reality. I am just going to talk about the geographic queries, because it's what brings us today, and the one that joined us with Born in a Box. So the geographic queries, the first thing that you're going to see when you enter the web page of the geographic queries is the consultation area. You have to select where you want to see this information. It's not just like a country level. We want it to be a little more adaptable depending on where you are standing from. So these consultation areas, for now, they are the administrative areas, thinking on decision-making, hydrographic zones, and environmental jurisdictions. Then, once you select your area, the idea is that you can see indicators in 4 different kinds of groups. The first 3 are the ones that are more implemented right now. And this has different, I'm not going to stop in every kind of indicator that we calculate here. But basically what we do is project those indicators, give area measurements, percentage. We cross those information with ecosystems that are important for this country. And the thing is with the decision making, and that is something I want to talk a little bit more in its portfolios, that we prioritize areas. Not just we as Biotablero, but we as the Institute. We have a lot of products about prioritization of areas depending on what we are wanting to prioritize. And what we are looking in the portfolio's geographic queries is that we cross that information with topic information like connectivity measurements or something like that to allow us to see how much of these topics are we collecting with the portfolios measurement. So that is something like, it's really cool about Biotablero, and we are implementing it right now, so it's a work in progress. And, well, the development process in Biotablero is long, because, as I said, we just don't want to focus, like we deciding everything. We made a lot of workshops and work with users, with other researchers. We use the information. We don't create most of the information that we are showing. So we work with the people who made that information also, with the engineers and all of that. So we have discussions. And that discussion is what helps us to decide how is going to be shown that information. What kind of graphic, what kind of maps, what kind of everything. Then we model the data and we do the calculations and we upload them. We have a testing period, an adjust period. These last steps are with a lot of work of our engineering team that without them, really, Biotablero couldn't be possible. And then we release the information. So we can do all of this once, and it's great. But we want also that Biotablero could be updated yearly, or it depends on the indicators, but the idea is that it's going to be updated. Yeah. So if we are including more indicators and updating the ones that we have, and all, it will be a lot of work. And we need to think about a tool that allows us to update this information without taking us that much of a work in time. So how we optimize this process? The answer is one in a box, of course. We are working in that workflows. We are talking all this week about one in a box in different panels, in different sessions. And what we wanted to do with this presentation is show you an example of how these workflows are implemented. It's not just some scripts in a page, in a Docker host, where you can run those pipelines. We are implementing them right now to update the information in Biotablero. So, Victor?
Okay, how can we say we are in the process to optimize Biotablero because it's a knowledge network. Our idea is that people has the feedback or has the skills to improve the tool all the time. And Bonina Box is a good idea to improve it. With the idea to improve BioTablero with Bonina Box, we had or we proposed some objectives to improve BioTablero that are organized in blocks. Our blocks are block 2, referred to enable access to integrate biodiversity data to empower rapid trend detection, and block 4, that is related with the label routines, data, metrics, and indicators to put in BioTablero. Today, I'm going to talk about block 4. That is mainly the idea to develop workflows to improve the idea to measure new things. But the idea to the feedback is very important for us too. So for that, with Bonina Box, we organize the indicators and the workflows of BioTablero in pipelines. That is the same logic of Bonina Box. So we have routines, scripts, steps that are organized with inputs, functions, and outputs, that all those things are organized in pipelines, like Bonina Box. That pipelines has specific inputs and very detailed documentation to use it in BioTablero, and are reflected like an input in BioTablero too. With this idea, the main objective or the context of block 4 is related to support decisions, support deciders by proving pipelines for estimate indicators, with the idea to provide pipelines to estimate it. For that, we developed the routines, and we set up those pipelines with a good documentation on the Bonina Box platform. With that, we developed new functionalities to BioTablero for indicator visualizations, and to use the Bonina Box like the backend of BioTablero. This is very interesting because it's easy to, it's a collaborative network, it's easy to replicate, has portability skills, and has a lot of different things. But the most important, or that we think that is most, or that has the most potential here, is the possibility that before we estimate things to specific areas. Camille said that hydrographical zones, administrative areas, and stuff like that. In this case, Bonina Box allow us estimate indicators in real time. So, for example, people can use different polygons or different areas to estimate this. I'm going to present you some indicators, some of the main indicators that we developed to BioTablero, founded in Bonina Box. We estimate an indicator to connectivity of protected areas, to persistences of human print, and forest and loss persistence. That indicators has different things in common. But we think that the most highlight, or I would like to highlight, that the three things or the three workflows to estimate these indicators are based on spatial analysis first. But not just spatial analysis. That indicators have a different step that are shared between workflows. So with Bonina Box, we have the potential to join steps to estimate new things. And the new indicators that we think, we can use these steps to estimate new things in different contexts. For example, we have a very simple step that is convert your study area to WKT file. This is a very common step in different workflows. And this is useful for our three indicators. You don't have to programming it again because you have that step for all that. And we organize this in pipelines. That is the logic of this. We use spatial analysis, and for optimize it, we use the stack catalog that are the better developed from analysis spatial data. And it's very interesting because this optimize our analysis. Because, for example, when you have a study area or when you have a specific window to analyze data, with a stack catalog, we have the possibility to download the specific extent or the specific VBox around that area. So we can estimate indicators, or we can run our pipelines or our workflows to that area. And, and that has better performance than other methodologies. The stack catalog has API access. We can download only the study area that we are going to estimate things, and it's easy to access and management of geospatial information. The first indicator is the PROTCON. PROTCON is an indicator to estimate the connectivity of protected areas. It's a very simple indicator. It's basically the evaluation or the assesses how are connected different areas in a specific window. The idea is that the pipeline starts with the geospatial data of your study area, and we organize in the second step the spatial units that you are analyzing in a distance matrix. We organize that in a distance matrix, and after that, we put it in a step that is the product function that basically estimate what is the percent or how much are connected the protected areas in that window of analysis. This is the pipeline of PRODCON, but furthermore, with the pipeline, we have a detailed documentation about it. This is very important because are the steps that are explaining the app or the pipeline and explain how to interpret the data that you get, how or what inputs do you need to estimate it, or different things that are important to understand what is the process that is run in the pipeline. The second indicator that we elaborate or that we work it is persistence of human footprint. That has a similar approach, but this is with raster data. We have the inputs that is our raster data from human print in Colombia in different years. So we use the stack catalog here. We organize the metadata of that ledgers in a collection. We load the collection in the cloud, and we can call for a specific study area the ledgers associated to that study area, and we estimate a very simple analysis when the persistent, when the human footprint change in different years, or that not change in other years. So we stack the layers and we calculate it. The results are areas with persistence of footprint that could be relevant to prioritize restoration and conservation actions. And the end result of this is a temporal map that shows these things. The three indicators that we work at in BioTablero is the forest loss and persistence. This is very interesting because it's a multi-temporal analysis of forests. Basically, we create a collection too with forests is the same sense or has the same logic that the human footprint, because we organize or we have data to forests in different periods of times. We load that with metadata in collection, and when we have to consult it, we download the data with BioTablero, and we estimate what is the persistence of loss of forests. Basically, is if during the time 1 have forest and in the time 2 don't have forest for the same pixel, you lost that forest. And if you have the forest in the 2 times, persistent the forest. The workflow is very similar and just change the last step. So it's the same pipeline in the 2 indicators, and we just change one function or one step that you create for your specific question works in both methodologies. The final output of loss of forest loss and persistence is a map with the areas of the persistence of loss for your study area, and the raster files to analyze if you like to run other analysis. The other important thing with this indicator is that it's the first indicator that we are tested to put in BioTablero for that the people can interactive or run the analysis with the different inputs. So this is a beta version of BioTablero when the people can draw their polygon, and when they draw the polygon, they can analyze different indicators in real time. So people put the polygon, draw the polygon, or load the polygon, and when they try to run, BioTablero is the backend, and it's in the server that run that analysis. So BioTablero captures the drawn polygon, send the query with parameters to box-in-a-box server, and in box-in-a-box, we run the script. This is an advance that the software engineers of Humboldt are developed. We developed the routines, and we send the routines to them, and they load it in BioTablero, and it's the capacity to run things in real time. This is the better example with forest and loss too. So in this example, people draw that polygon, and the results are in different temporal or different times the deforestation of forest and loss persistent that they need or that they can use to make decisions. With this experience, we can reflection that Bonina Box allow optimize workflows in these kind of tools like BioTablero. And it's very important because we first avoid reprocessing, and also people has the documentation to understand the process that they are run. It facilitates the maintenance of the code, because sometimes it's hard to review or check all the scripts that are support the apps. And in this case, you can check the specific steps or update all the time your analysis if you have a new paradigm to analyze data. Along Bonina Box continues to develop it, we think that could be solve different needs of scientists and could be a powerful tool. And we think that by making these workflows available for GeoBank community, we have that users and people and scientists share the knowledge and favoring the constant replicability of these methodologies to share knowledge that and to create the network of knowledge that is the objective of GeoBank. Thank you.
Thank you very much for your informative presentation. So I would like to take one quick questions. Yeah, Petli. Petli, and then, yeah. You can use that mic and also.
Depends on the question.
Okay, yeah, here's the microphone working. So thanks for the great presentation. My question relates for this like raw data, what is like origin of your pipelines. So do you have some collaboration with GBIF? Do you have a national GBIF node, or where do you storage all this biodiversity data that you start to use for your pipelines and different indicator calculations? Is it part of BioTablero also?
Okay, we have the possibility to use different tools from different sources. So, for example, we can, or we have developed other indicators when we collaborate with other organizations. But in this case, and for example, we are developing an indicator related with Red List. That is a very useful too. So we use the APIs of different sources to run that things, and we can use different things.
I have to add something. Most of the indicators we are calculating right now, we are using national information because it's the one that it's official and we have it in a low scale for our country. But in the pipelines, we talked about that, like if we wanted to other people to use it around the globe, we need to make it easier for them to either upload their own information or to use the global intakes. So that is something that we are thinking about, and it's something that is possible right now.
A very quick question. This is really amazing. Thank you, both of you.
Thank you.
Is there a limit on how many people can use the bottom box at a time? Like, say it becomes very popular, will there be any lag time if a lot of people are using it at the same time from many countries, for example? Does it make sense? I mean, if like a lot of people are using it simultaneously, is there any limits on computation?
Yeah, I think it's more like a question for Jean-Michel.
Yeah.
Okay, thank you.
So Humboldt installed their own version of Bon in a Box, so they have it run it locally, and that's what we would propose for most countries who want to have something as elaborate as what Humboldt is doing, is to install it locally. So they would have to manage the load on the Bon in a Box server that they're running. So it's not like one Bon in a Box server instance that runs all the country's pipelines.
Thank you very much. So please give your big hands again. So next, I would like to invite Petteri from Shuke that presenting about the Finland network. Thanks.
Okay, here again. Can I get the slides, please? Okay, now we go to Finland, and I'm gonna explain what we have been doing in Finland establishing Finnish ecosystem observatory, kind of FinBon, national cooperation model for bridging biodiversity data providers and users. So very similar like what we heard already, but now from the boreal forest of the Finland. This is how the situation has developed over the last 100 years in Finland. So there have been different kind of biodiversity monitoring schemes, basically in situ schemes on the upper part of the arrow, popping up every now and then. First there was a demand to get information of the forests, to get trees logged. Then there were some information that there were reindeers were dying, so we needed a little bit more information about the lichen pastures, so we established a new monitoring scheme. Then there were some observations that the Baltic Sea is getting too much nutrients, so we established a monitoring scheme for measuring chlorophyll alpha at Baltic Sea. And then more and more in situ monitoring schemes, really ad hoc monitoring schemes without not strategic thinking or any kind of coordination. They have been popping up over the years. And now we are in a situation that we have all kinds of schemes which are not discussing with each other, they are not coordinated, they have really troubles to get funded over the time. And that's the like a current situation where we started. At the same time, there have been luckily more and more different remote sensing opportunities available, which can maybe fill in some gaps, maybe some wall-to-wall maps for different phenomena what we would like to monitor. But anyway, it's like really quite a difficult situation, and that was also the backbone why we thought that this kind of maybe coordinated national effort is really needed in the future, and to guarantee that there will be long-term ecosystem monitoring and biodiversity monitoring also in the future. So we try to find out some solutions for that at the moment. Oh, font has changed, but that doesn't matter. So what is FEO, Finnish Ecosystem Observatory? It's currently a national development project with a budget of 6.3 million euros, and we are coming to the end April next year. In addition to that, we have 4 spin-off projects focusing for automated species indicators development, a national eDNA roadmap that was presented by my colleague Tiina Lamanen yesterday in one of the sessions here. Then Earth observation for habitat detection in Finnish Lapland, and habitat monitoring of Finland. We work in close collaboration with Biodiversity Plus, Europapon, and Geopon, and we wanted to get cross-cutting themes, both biodiversity monitoring, species and habitats, but also ecosystem processes like carbon and nutrient cycling, because we think that these are really crucial to keep in a close loop with the biodiversity, because they are, it gives more power to understand what are the changes in the ecosystem and how, not to separate like climate community, which wants to know just about the carbon stocks, but also to bring that together with biodiversity observations. And we are focusing for 3 key topics: management of the data interoperability, modernizing biodiversity monitoring methods like eDNA, Earth observations, artificial intelligence as much as possible, at least to find out the possibilities for the future, and then integrating the knowledge and for the different decision making at various scales. Would like to advertise a nice paper that came out a couple of years ago in Science 21. It's not about Jupiter storms, but this promise of satellite monitoring for preserving biodiversity. There was an editor, Elisabeth Pennisi, making nice article interviewing quite many Geopon colleagues also for that, to get a big picture of the biodiversity change, and it also refers for Geopon that recommends countries and regions to set up biodiversity observation networks, analogies to existing national climate observatories that will allow each country to measure biodiversity. So we talk about GPOs in that case. And it also refers for our national FEO project, so we were of course happy of that opportunity. EBVs were as a backbone for this article, also how to provide information for different EBV classes, which is crucial. In Finland, there's a really lot of need for biodiversity information supporting decision making. Sorry for the small font, but it was bigger on my laptop, but I try to see. So, for example, in Finland, we are reporting for conventional biological diversity. Our institute is in charge of that. Ministry of Environment shows that Syke has to do that job, so we do that job. And then we need to report for different directives for European Union. More and more, we need to also provide official ecosystem accounting data for ecosystem extent, ecosystem condition for Eurostat.
which follows the United Nations CAA guidelines. Then we have national legislation which needs monitoring data. We synthesize and coordinate red list assessments for species and habitats. That happens every 10 years in Finland. And in addition to that, there's more and more need for land use planning, environmental impact assessment. Different private companies would like to get biodiversity information to calculate their sustainability footprints and that kind of things. So these are like customers for this biodiversity data in our case. And that was the reason why we decided to demonstrate biodiversity monitoring data use for 5 different cases. So national biodiversity indicator development, habitat directive reporting, carbon neutral land use planning, biodiversity data for municipalities which are really hungry on biodiversity data for their land use planning and that kind of things. And then finally ecosystem accounting as well. So FAIR project synthesized these different data sources into remote sensing models data, and especially we try to focus for this central system, like engine, motor of this findability and accessibility of all the biodiversity data. So we are trying to set up a system where different data streams can be findable and maybe then available for whoever it needs. In the beginning, we decided that we have to work both with more like a raw data, nature data side, but then also with the indicators, which are then more tailored for the different end-use purposes. And then finally, there are these 5 cases which illustrate the data use across the society. A little bit same figure, but anyway, we wanted to have this like bidirectional exchange of information and understanding that from data to information. That's of course quite often the perspective how scientists are thinking, that we want to know everything about what's going on with biodiversity. But then we have to be aware that there's a lot of policy needs, so how policy needs could tailor the information products and then maybe provide resources for these monitoring networks. So we have been trying to cover these loops to all directions. This is just boring work package structure, but I would like to highlight this below here, in situ remote sensing modeling work packages, which I will give a short example shortly, and then this machine there in the middle, which brings these data streams available, and then the use cases and the policy processes there on top of that. So if you look first for this in situ data, we have been going through the whole landscape of different field inventory data and observation networks in Finland. So we have been focusing especially for these molecular monitoring methods and their possibilities. We developed this roadmap for implementing environmental DNA and other molecular methods in Finland for different biodiversity monitoring purposes in the future. Then we have assessed all the systematic species inventory schemes, which are totally, nowadays I think there are 90 different schemes which have been more or less interviewed and analyzed. They have a small groups of experts, some coordinator, and all this have been tried to be mapped and bring together. Then we have made a mapping of old habitat type inventories. We have digitized and tried to get these polygons on the map covering the Finnish landscapes to provide also in situ data for monitoring. And then we have been also working with these carbon concentration and balances measurements, which are quite often also linked with the ELTER network, long-term ecological research network sites. Then with the models, we have also tried to get a better understanding what kind of biodiversity models there are used, what kind of expertise we have, where they could be used. So it's really also like a universe of all kind of different approaches. So how different models could provide information. And we have been especially focusing for different kind of topics, like developing understanding of the key drivers of species habitat conservation concern, filling spatial gaps, so spatial distribution models, possibilities in that case to provide better data products and, for example, EBVs. Then we have been checking the models which are determining factors affecting greenhouse gas emissions, carbon sequestration, and carbon stocks, which is important for Finland, of our forest industry and forest natural resources. Then also assess support monitoring of land use impacts on biodiversity, carbon sink stocks, and greenhouse gas emissions. And define best practices for reaching carbon neutral society. And just a couple of illustrations from the publications done during that work.
then a couple of more words about the possibilities of remote sensing in the use of biodiversity monitoring. So that we have been approaching first from that point of view that we have wanted to find the ways how Earth observations could really support biodiversity monitoring and assessment. Then we have collected some new Earth observation data and made some data products which support biodiversity monitoring. And then we have been also paid attention that what are the possibilities to really make this processing and managing sharing of big data available in a most sustainable way, and quite a lot of cloud computing is used for that. In Finland we have one of the world's biggest supercomputer, Lumi, so that has been providing support also for calculating some of the data sets. Different data products have been listed here, which are done during the process and which are important for not directly always giving information about the biodiversity, but at least as a background information, parameters, features which could feed in and could be integrated for different biodiversity indexes or assessments or indicators. So quite a lot of different products. But anyway, as we are really focusing for operational remote sensing data products, that's the reason why we have tried to use those satellite data which are openly available and have a long-term archive. So we have been especially focusing with the Sentinel-1 and 2, and in addition to that, we have every 5-year cycle we are having a new LiDAR data covering whole Finland that's based on the airborne campaigns. It started with 0.5 pulses per square meter, but second campaign was already 5 pulses per square meter, and now the new campaign is designed to be something like 15 pulses per square meter. So it's giving more and more detailed information of the vegetation structure all over the Finland. But of course, it's like a puzzle of the 5 years, different flights all over the Finland here and there. So these are the data sources that have been used quite a lot. And a case example is now coming from the Finnish Lapland, which is a huge area over 30,000 square kilometers, where we have tried to develop a habitat classification method based on machine learning and expert models to provide information for habitat directive, national habitat assessments. So that work has been quite intensively done in collaboration with Finnish Forest and Parks Services, Metsähallitus. We started with the Earth observation data, then there was 3 years of intensive field campaigns. We got altogether 4,500 field plots invented, which provide this kind of calibration, validation material then for the remote sensing products, and then classifications, validation, habitat classification, and repeating this cycle to get meaningful products. And that was a very successful process. Over 20 Earth observation features were provided to support this kind of mapping of the habitats. And we are planning to continue that with the different habitats in the future. Then another example is focusing for ecosystem condition assessment based on remote sensing. Our colleague Tytti Jussila has been working with this case, where we try to quantify wetness variability in Aapamajos, which is a special kind of wetland priority habitat of European Union Habitat Directive, to provide time series data of the exchanges of the condition of these Aapamajos across the whole Finland. And that data was very promising and interesting also for a long-term monitoring to estimate the condition and the changes and the maybe impact of the restoration activities to the condition of these habitats. Then we have been working quite a lot with different deep learning algorithms to try to detect interesting biodiversity features. So my colleague Janne Mäyrä was working, for instance, with the airborne hyperspectral LiDAR data to try to map aspens in a small-scale area, but anyway, kind of like learning how this kind of approaches could be applied in the future when we have these hyperspectral satellite missions data available to really build capacities for these coming times already. So that has been a really nice example also. And then some other colleagues working with the habitat classification based on deep learning algorithms as well. Finally, coming to this interoperability system, this machine I explained to you, the main goal is really have been to develop accessibility and management, publication of the methods and interoperability of biodiversity and habitat-related data,
We have been doing different kind of nature data architectures, recommendations to uniform documentation of habitat data processing workflows, then publications of habitat type datasets, metadata service for biodiversity using hashtag FAO when you have a data what you would like to find from this system, and then a national coordination group for nature information in general. And how this everything is packaged in the future, we are currently working with the nature data and information portal for Finland, which is hopefully then giving a one door for our gateway to the Finnish biodiversity data. It promotes the understanding of the big picture, how the biodiversity is doing in Finland, what are the states of and trends of biodiversity elements, and also present the Finnish biodiversity ecosystem monitoring data and methods. And we have 3 different segments here. So we have a metadata search, which is very much for the expert use tailored module. Then we have a methods database, which describes all the available biodiversity monitoring schemes, and also some methodologies and like a standardized protocols for eDNA sampling, for instance, to give guidance for anyone who is interested in that. And then on the right side, it's the most like applied part of this. It provides the indicators and different kind of like a tailored data products for different use, and also other data provider services available from that way. And we really try to serve different users, researchers, experts, but the wider society. We have a special collaboration with the teacher education group, which is developing information for basic schools about the biodiversity and ecosystems and that kind of things. Just last example, which is very much referring to the BioTablero example also. We are also currently revising our national biodiversity indicators, which we are reporting for the CPD, and also they are part of the national biodiversity strategy and the EU biodiversity strategy, which needs to be reported. So we have colleagues who have been working with this topic, reviewing this system. There's approximately maybe 50 state indicators defined, and for every indicator, there's a pipeline from the data provider have been defined. We really try to also automatize that as far as possible. Previously, we had much more indicators, and they were handmade, and it was just impossible to keep them updated by our resources. So now we are building these pipelines that we really try to get this, when the data updates in the data storage, we can get it from the API, and then we have our indicator automatization process with acquires data, restructures, shapes data, have statistical models used if needed, indicator output, and then indicator visualization in the end. And this will be part of this new web page, also launched by the end of this month. And just example of the water quality and what is the data source there, what kind of steps there have been, and then describing the trend. And the next year, when you get new data, you just run the script and get the updated figures for the indicator. So what's next? We are coming to the end with the project. We would like to keep this FAO alive and hopefully continue with that. But at the same time, we realized that we really need to work in a closer collaboration with all data providers and all data users. And we have, during this year, established a national working group which includes 17 organizations, 3 ministries, Ministry of Environment, Ministry of Forestry and Agriculture, and maybe most importantly, also Ministry of the Finance. And with their support, we really try to get a solution and recommendation for a 10-year program for Finland, how national nature information development should be developed in the future. The name of the program is Lukki, which means spider because of all the networks. And the main aim is to really establish this kind of national coordination hub for biodiversity ecosystem monitoring, focusing 3 themes or subgroups: monitoring, data interoperability, new methods, and the use of data. And then our solution really would be to keep these BIFs and bonds, as Tim Hirsch mentioned it yesterday at some point, together, so that GBIF data and the biodiversity observation network and remote sensing-based, maybe FAO kind of data, could be really supporting each others and available for meaningful monitoring and assessment purposes. And that's it. Thanks everybody for your attention. I'm happy to answer questions.
Hello everyone, I'm Masa Nakaoka from Hokkaido, Japan. And today I'll talk about our activity on AP bone. Hiroyuki just mentioned in the past session about AP bone, but it has M inside, that is marine. And I will talk about the status of marine biodiversity monitoring in nearshore areas of East and Southeast Asia with a lot of collaborators in our region. Okay, I think most of you know, for marine biodiversity, Asia-Pacific, East Pacific, especially Eastern and Southeastern Asian region is a hot spot for a variety of different type of marine animals and plants. But we have fewer data compared to the US or Europe or Australia about the status of this region. The picture map below is a paper by Waycott showing the global decline of seagrass bed, but there's only 1 or 2 contributions from our region until 2010. Okay, so this is a quite big motivation for us to do something by network for understanding our marine biodiversity status in our network, in our region. So we make a subgroup of geobond called APM-bond. Actually, it is a mixture or the partial part of the M-bond, Marine Biodiversity Network. It is one of the thematic bond. And AP-bond is a regional bond of geobond. So marine researchers in our region, also belonging to M-bond, actually try to do some co-joint work. And the APM-bond was established in 2019, and our mission is to, missions are written here, promoting monitoring and research and new technology development. And number 4 and number 5 is capacity building and outreach or link to society. Today, I will talk about mission 1. So I think everybody can understand monitoring is one of the most important for any type of ecosystem conservation or restoration or management, even at local or national or international level. And geobond is actually, we need this type of scheme to help any policymakers or decision makers or local stakeholders to conserve or sustainably manage precious ecosystems. But for the monitoring, current status is actually we haven't understand exactly what is going on in each country of Asia. So what we did is actually we made and sent a questionnaire to AP-bond member. Actually, it was made by Hiroyuki and other members of AP-bond, but we made some modifications that marine sectors can answer to the questionnaire. And I don't give any detailed information about the contents of questionnaire, but actually we are very lazy, but we finish making it and sending to our own members by September, and within 1 month, we got a reply from 11 members from 7 countries and regions listed, written here. So most of them are researchers working in university or national institutions, but there's also a reply from the governmental manager for the responsible for national level marine diversity network monitoring. This is a type of ecosystems they are observing in their marine biodiversity monitoring programs. So including coral reef, mangrove, seagrass, and seaweed bed, rocky intertidal and tidal flat, quite a lot of diverse in each country, especially in Japan, Korea, and Philippines. And for the, I think it is just, it is not comprehensive at all. So it is just a case study. So we can explore and find more monitoring programs, but it's actually, we need a longer time to gather more information, but this is the status at the moment. And in the case of Malaysia, they report there's a long-term monitoring of marine fish, actually covering the different type of ecosystems, and it's actually has been done for over 50 years. Okay, what type of variables they are observing. It is actually, in the case of GeoBond, it is EBVs. In most of the monitoring programs, species occurrence, presence data or presence absence data or abundance number or coverage or biomass has been collected in all the monitoring programs. And except for one, actually community structure is also monitored, has been monitoring. Sometimes it is only presence absence list. In that case, it is just a species list. For other important variables like species traits or genetic information, some program has tried to monitor, but it's not widespread, including ecosystem structure or ecosystem functions or services sensors. In contrast, actually, many program here focuses on the actually analyzing impacts from disturbance, natural or human-caused disturbances. It is actually really interesting, but we found that most of the program are actually very short-term and target-oriented. Actually, they start, for example, one program in the Philippines is actually started after, in Taiwan. The mangrove monitoring program is started just after the large loss of a mangrove or a kind of plantation, rehabilitation program, which is actually not suitable for the conservation. That means they are planting in seagrass bed. Okay. So I will show you one example. It is one of the most successful programs in our region. Actually, it is from Japan. The Ministry of the Environment, Japan, has been conducting the nationwide monitoring program called Monitoring Sites 1000. 1000 means a number of sites, and they are very ambitious. They actually declares they will continue this program for the whole 21st century. So we have to try, keep doing it for another 77 years, okay? And most of the site is a terrestrial or forest or grassland, but actually there's some marine sites, 28 coastal sites, tidal flats, rocky intertidal, seagrass bed, and algal bed, which is a typical coastal ecosystem in temperate region of Japan. But we have 27 coral reef monitoring sites, which started earlier than other coastal sites. But as you know, coral reef only locates in the southernmost part of Japan. Actually, recently, they are actually coming north. So it is quite interesting, but I don't have time to talk about it today. And for the seagrass bed, for example, it started since 2009. So we have now nearly 15 years of data. And this is just one case study in the result of one site in Hokkaido, Akeshi, where I've been studying. So there's the bar here shows a change in the coverage by species. So you can see there's a large fluctuation. Sometimes it gets more than 50%, and sometimes it goes down to less than 10%. And we already know the reason why this type of fluctuation occurs. It is because of it is estuary ecosystems affected by the river inputs from the major river. And whenever there's a big, heavy rain due to big typhoons or other causes, it actually decreases. It leads to the massive decline of seagrass bed. But seagrass can grow rapidly back within a year or two. So it is quite, by doing annual census, we can understand what is responsible for the variation in biodiversity. And we are also collecting data on benthic animals here. And more importantly, for the Monitoring Site 1000 Coastal Program, this data we collected is actually already open to public within a year or two. Then I think every 3 or 4 years, we summarize data and submit it to Orbis. So it is now widely available through Orbis, so you can use it too. That is a case study in Japan, but we only have 28 sites, and for the coral reef, 27 sites, and I don't think it is enough number to cover to understand the change in whole coastline of Japan. But even though we have doing successfully so far, and we actually ask our members what is the situation in each country, and here's a kind of result we collected from different countries of Asia and the Philippines. There are the 3 programs reported by different members. As you see, there's a lot of challenges here. For example, some of the a good program has already ended. In the case of Indonesia, there's a big program called COREMAP, especially focusing on the change in the coral reef ecosystems. And it has been, actually, it's ended by 2019, and they're trying to restart it by getting funding, but so far it's not so successful. The same for another program in Indonesia and Malaysia. In the case of Malaysia, it started in 1972, but ended in 2016. So it's really pity if that is a situation they cannot resume. I hope they can resume soon. And another problem or challenge is access of data is very limited in most of the cases, because it is, most of the cases, they are run by the individual researchers fund. So they have to first need to write a paper until they open the data to the public. Okay, here's an answer to the free answer to the question, what are the major challenges to continue the monitoring program in your site? So you can see a lot of answers, but as I put it in red, of course, resources is all the time, budget and funding and manpower is a big issue in most of the programs. I think it is a worldwide same problem. But there's several important answers, like not only funding, but community engagement, or with local citizens or local NGOs and local government units is important. And the connection between collected data and decision making. So not only not only complaining about the resource limitation, we need to do more networking with not only among scientists, but local citizens and decision makers. Okay, it is not a major issue. Another issue is actually language problems. As most of the success program are relying on citizens and the local governors, it is mandatory to have this report or data in each language. So you can see, in the case of Philippines, most of the data was published in English, so it's okay. But for other Asian countries, it's first given in local languages, and someone has to translate. So there's another effort we need to do. And it is too small to see, but in the case of Japanese monitoring site 1000, there's actually English page already established, but you can see in the red line, all the report is written in Japanese, and someone has to translate it. Automatic translator is now developing so rapidly, it may solve this problem or not. Okay, so how can we link the output of monitoring programs to the global biodiversity observation systems, which is actually topic of this session? So there's a lot of good answers. So more systematic approach or beyond voluntary efforts, cooperation with the institute, and especially memorandum of understanding may be important to ask institute to do it regularly, and most of the case, local researcher, scientists themselves has enough knowledge, do not have enough knowledge for the importance of these global biodiversity database. So we need more education. Okay, so some take-home messages, but I'm running up time, so thank you very much for listening to my talk.
Thank you, Masahiro. Is there some question? So I have one for you. As AP Hembon, you're part of two bonds, the AP bonds and the marine bonds. How do you feel about that? Is it easy to work with two different overarching bonds?
Yes, actually it is voluntary members, actually belonging to either bonds. But as we don't have any rigid fund, except for small research fund. So I think we are still free to, we don't engage everyone to restrict to any type of bonds at the moment. So it is free to come and free to go.
Okay, and what would you need to do your job better as AP Marine Bond? Do you need more?
I think we need more networking first, because still, I think it is the same with AP Bond. So there's many good scientists around the Asian region, but not many members are interested in international, actually not still understand the importance of international activities. So I think outreaching and networking is one most important, among all, most important thing we need to do as a first step.
Okay, thank you.
Thank you very much.
And now we can welcome our host, actually, Sabrina Courant from Quebec and from the government of Quebec.
So good morning, everyone. I'm Sabrina Courant. I'm working for the government of Quebec, the Ministry for the Environment. And so I'm happy to be here today, and I represent a whole bunch of people working with me in implementing a biodiversity monitoring network in the province of Quebec. So for those who were at the panel organized by Alberta and Quebec on Tuesday, you had the chance to see how partnership was key in all steps necessary to implement and maintain such network. And today I will present an overview of what is the Quebec Biodiversity Monitoring Network, how it works, and how it will allow us to answer spatial and temporal changes in biodiversity in the long term. So the idea of implementing a biodiversity monitoring network in the province has been in the mind of former colleagues for a while now. And we've heard it a lot in the last 4 days, but starting a project is often just a question of funds availability. And we're not different from others, and even if we're from the government of Quebec. And with the launch of the Climate Change Action Plan in 2013, we had the opportunity to start a biodiversity monitoring network that would primarily respond to the question how climate change will impact biodiversity in the province of Quebec. So I won't explain to you how biodiversity and climate change are interlinked. You are all very well aware of it. But as a reminder, you'll find behind me a quote that we'll find in the 2019 IPBES Global Assessment Report, and I won't read it since we're a little bit late in the schedule. So with that in mind, what is the Quebec Biodiversity Monitoring Network? Boy, we have a problem with the, okay. So it is an ongoing work since 2013, during which we had the chance to work with over 50 experts to select indicators in six types of ecosystems. It is a project funded by the Plan for a Green Economy with an annual budget of approximately $1 million Canadian. And it's allowed us to monitor more than 4,000 sites monitored since 2016, and to work with academic partners to launch an online platform to communicate biodiversity data at COP15. And with a vision to detect changes in biodiversity in the context of climate change, it is really important just to be able to remember that we want to detect changes, not only monitor. It's really detecting changes. The project has 3 objectives. So detecting changes, I've already said it, in the state of ecosystems, communities, and population. Second one is linking our monitoring program with other existing programs in Quebec. So the main idea here was not to reinvent or invent new monitoring methods, but to add on existing initiatives. And so we were trying to complement existing methods, add new ones if needed, for sure, and standardize them. Okay, standardization is a great challenge, and we've heard it a lot since the last 4 days. And the third objective is to enhance awareness and information tools. And all these objectives tend to reach long-term goals, such as pinpoint and promote effective climate change adaptation measures, base conservation decisions on current knowledge, and also respect our governmental, national, and international commitments as some national government that we are. So, as mentioned previously in my presentation, we had the chance to work with over 50 scientists coming from university and governmental departments. And I'd say after more or less 3 meetings per ecosystem, we selected a set of 75 indicators that are interesting to accurately detect changes in biodiversity in Quebec. Obviously, we are not able to implement all of them simultaneously, and we have currently 20 active field indicators and 7 from remote sensing methods. So I'll give you 2 examples on the kind of indicators or measurements that were selected by the experts. In forests, for example, it goes from the distribution of trees or vegetation phenology by NDVI to ground insects or decomposition of organic matter. In wetlands, I'm sorry for the title. You miss so much of my presentation. So in wetlands, it goes from NDVI measurements to butterflies and changes in water levels in marshes. So you will notice that these indicators we're selecting for 2 things. We have different spatial scales from the landscape to the species level, and we are not only able to study changes in one indicator, but also trying to study how they interact and influence each other. Selecting where to implement monitoring surveys was also another challenge. Quebec is a very vast province with a territory 3 times the size of France. Moreover, about 50% of the territory is only accessible by helicopter. So how can we detect changes in biodiversity in a cost-efficiently, but still scientifically relevant manner? So we applied a 50 by 50 kilometer cell grid on Quebec, and then considering existing monitoring initiatives, accessibility, representativeness, and presence of protected areas, we plan to monitor 440 monitoring units, which approximately 60% of them are field work. We have 40% of monitoring units where fieldwork is possible, and the other 40% relies only on remote sensing indicators. So in the map here, like at the left for you, red dots are where fieldwork is possible, and blue dots as well, and all the yellow dots are where it's only remote sensing indicators. And each monitoring unit is visited every 5 years. From my point of view, one strength of the Quebec Biodiversity Monitoring Network is that every time we have a partner contacting us to participate, we have a complete package to offer them. Standardized methods, a sampling calendar, video recording information sessions, and all the tools needed in the field, such as cameras or acoustic equipment. Of course, it does not solve all the problems, but we keep improving each year on how to work with our field partners. And of course, with all the different types of data we gather, we try to use innovative methods to communicate to identify or analyze this great amount of data when it is possible. So this is the case for eDNA, or like using artificial intelligence to automate the recognition of sounds, animals, or plants. We've heard a lot of very good examples here in Montreal on how these new technologies are able to improve our ability to identify or analyze more quickly biodiversity data, so I won't spend too much time on this slide. And finally, the project gave us the chance to work not only on how to analyze the data, but how to communicate the result of our field campaigns, how to give access to our data, and how to present more complex indices. Like a little bit earlier this morning, Dominique Ravel was presented, like the whole story of behind Biodiversité Québec. And to do so, we had a great exchange with multidisciplinary teams. So scientists, of course, but also design thinking experts, web designer, journalists, school professors, NGOs coming from the conservation side in Quebec. And so all this work led to a new scientific partnership with the University of Sherbrooke and the Quebec Center for Biodiversity Science that resulted in the launch of an online platform at COP15, where the data of our biodiversity monitoring network are presented and aggregated with other data available in the province of Quebec to produce dashboards useful to understand changes in biodiversity. So in conclusion, I think that we have the basis for a biodiversity monitoring network that will give Quebec the capacity in the long term. We have data only since 2016, so if like do the calculation and we revisit every 5 years, we're just starting to revisit sites. But in the long term, it will allow us to measure species data that respond rapidly to environmental changes, better evaluate the integrity of our ecosystem, better assess the climate gradient of biodiversity, improve our ability to predict trends in biodiversity in a changing climate, and with Biodiversité Québec will allow us to make tangible data on biodiversity available to a broad audience and work with different stakeholders and develop a vast network of collaborators. So I will let you with a final quote from Winston Churchill that say, "We must take change by the hand, or rest assured change will take us by the throat." Thank you so much.
Thank you a lot. Some question for Sabrina?
Yeah, thank you for the presentation. Sounds very similar challenges what we have in Finland, which is also few people and a lot of empty spaces in the north. So how do you feel this application of remote sensing? Is there some particular organization in charge of developing this remote sensing-based monitoring, or?
Well, we have a person that is in charge of remote sensing, developing remote sensing indicators at the government. And we, of course, need, like also universities to do so. So it depends really on what we have as, images within the government of Quebec. We have, like a really great list of imagery that is available, but it's much more like expertise that is mainly a problem. So when we need, we turn to universities. So, and there's lots of remote sensing data that is already available, like for example, fires or disease. This is already something that the government of Quebec has as data. Again, we don't do a new method, so we just use what's available. And yeah.
And related to that, there's this Canadian airborne observatory system, some kind of like an airborne fleet which is collecting data. Are you collaborating with them also, or is it some other provinces then which are more
in Canada?
Yeah, CABO.
Sorry?
Canadian airborne biodiversity
Yeah, well,
observatory.
I know there's some people thinking of having a Canada bond. Andy is working with other people to convince. It's possible, but it's also a challenge in Canada because we are provinces and territories, and we have a federal government. And you have not only to have the federal government behind you, you have to all the provinces and territories. So it's a little bit more challenging since, like every province has its own jurisdiction, competencies, and so on. So yeah, it's possible, but it's feasible, but it will ask lots of exchanges between the province and territories. And it will be much easier if it was, to come from the province and territories that would, gather to have a Canada bond than coming from the federal side or federal government.
Timescales on which you report back to the government on these 75 indicators? Do you have to pull it all together every year and get it into the hands of those who fund you so that they make decisions about what they're going to be doing for the next year?
Yeah, well, we are kind of lucky, I'd say, because we don't have to report every year. They know that we revisit sites, like every 5 years, and because we're funded by a program coming from the government, and it's a long-term program. So, like for example, the plan for a green economy started in 2021, and it's until 2030. So basically, they will ask us only report in 2030, not really before. So we have kind of, we're lucky. Yeah.
Thanks so much for the talk. I was wondering, so about those 75 indicators, I'm sorry if I missed it, but to what degree are those driven by and aligned with the CBD indicators? Will you be producing a Quebec-level subnational report to the CBD? And just in general, how much of the monitoring is driven by the CBD priorities?
It is not driven by the CBD priorities at first. In Quebec, we're actually writing our next strategy to respond to the Kunming Biodiversity Framework. So with this next strategy, which is called the Nature Plan, we'll have to report, and we'll use what we have here and other indicators as well to try to be more close to what the TBD priorities has. And we have actually we have a group of experts that is going on right now and to just analyze all the indicators, the headline indicators of the CBD, and see how it is possible to implement it in Quebec. Do we have the data? Do we if there are any gaps in the data? So it will come to, and we obviously hope that the monitoring biodiversity network will help, and we will be able to use some data. Thank you.
Another question? Maybe we can take one more. I will have one. How do you include national parks in your monitoring programs? Because I guess they have also their own needs at a finer scale than national as Quebec.
National meaning national Canada or national Quebec? Because here, when you talk about the national level, mostly it's Canada, it's Quebec. The federal level, it's Canada. So you just to make sure.
The one you're working with.
Okay, so working at the national level, but that for the international level is the subnational level, since we are subnational governments and not the national one from the CBD perspective. Yeah, it's always kind of complicated to explain it. But yeah, so we. Sorry, can you remind me the question because I lost it?
How do you work with Quebec? The Quebec national parks for monitoring, because I guess they have their own needs of monitoring at their own scale.
Yeah. So we tend to as Quebec and as subnational government, we tend to. Have we have the vision that we as subnational government has to report directly to the CBD and not go through federal government. So we participate, the federal government, they have access to some data that are accessible to the public, and so they use it. But we don't really share everything with the federal government. So so when they report to the CBD, they use only what's available in the public part of it. I don't know if it answered the question.
No, but that's fine. I got other answers. So thank you very much, Sabine. And the next speaker is Mark Grant from Australia, and I guess their wonderful TERN experience.
Hi everyone, thank you for the introduction. My name's Mark Grant. I'm from TERN, Australia's ecosystem research infrastructure. I'm here today to tell you about ecosystem monitoring in the Oceania region. So just in case you've forgotten, this is the Oceania region. There's 26 countries in it. And there's already some fantastic ecosystem monitoring efforts happening in this region, and at multiple different scales. So at the local scale, you have a lot of hypothesis-driven research that operates out of universities, for example. And in particular, I'll mention the University of the South Pacific, which operates across multiple different local regions. At the national scale, you have organisations such as TERN Australia and Manaaki Whenua in New Zealand. So they operate, obviously, broad-scale monitoring efforts across continental scales in some cases. At the regional scale, you have groups such as the Pacific Community that coordinate multinational monitoring. So across multiple different countries that's coordinated through one organisation. And then you have projects that have global links. So for example, the FAO, they operate a number of monitoring projects throughout the region, particularly good one in Papua New Guinea. And then I'll also mention the Global Soil Partnership, which operates throughout the region with some fantastic results. So monitoring is happening and it's outstanding, but because there are different agendas for this monitoring, so for example, there's some monitorings happening for economic accounting regions, so carbon and biodiversity credit accounting, for example, and some is happening for monitoring ecosystem services, for understanding food security, water security. So because of those different agendas, what's happening is there's a myriad of variables, data on a myriad of variables is being collected, often using different methods and standards, and there are gaps over time and space. And quite commonly, we're reporting on states, but not trends. So we're painting this picture that's pretty good, and we can understand sort of what's happening, but it's incomplete. And this lack of interoperability between data sets is a key constraint for these big macroecology studies and modelling, and then appropriately for this conference, impact and decision making. So a group of people have been thinking about whether or not there's a case for creating an Oceania bond. And so the aim of this piece of scoping work is to create or to scope the creation of a regional community of biodiversity data providers and users that share the best available information and data, tools, resources for monitoring, integration, and analysis. So it's about bringing together those different pictures throughout the region and making them clearer to build up an overall picture of what's happening in this region. So when we started this piece of thinking, we obviously realized that we had to come up with a proposal or a clear reasoning as to why a GeoBond, an Oceania bond would work for this region. And it was structured around 4 key things. So the first one is that there's this scientifically robust framework for monitoring that would be of use to the region. 2, there's this pathway already created for sharing and networking, which is really important. There's a platform that helps prioritize interventions to address any change in biodiversity that's not wanted. And then finally, there's links to global efforts, so this global community of practice like we're here to join in. And of course, a presentation at this conference wouldn't be complete without a slide like this, but we have done some thinking around how a Oceania bond could help these countries contribute to the Kunming Montreal Global Biodiversity Framework. I've highlighted the specific targets that I think are particularly relevant, but there's more. But I will note that, especially in this region, we also can't forget about the SDGs. A lot of this region, there's a lot of aid money flowing to this region, and the SDGs are still the primary targets that are used. So both of those two frameworks and targets need to be kept in the front of mind. So in addition to our value proposition for an Oceania bond, we also obviously need to think about the needs. So we don't want to create something if it's not needed. So we've done some work looking at some needs assessment reports that have been done. And in particular, there's this one in 2021 that was being put together by Digital Earth Pacific, which is part of the Pacific Community Group. And it pulled out a number of key priority areas, and I've put the tier 1 priority areas up there for you. And you can see that some, if not all of these tier 1 priority areas would have, or an Oceania bond would be able to help address some of these. So, for example, disaster management. Disaster management is huge in the Oceania region, and so an Oceania bond may be able to assist with the identification, monitoring, and protection of green infrastructure, for example, mangroves, with then co-benefits for biodiversity conservation. And that's just one example. So on the flip side then, what can Oceania offer GeoBond and the planet? So this is a slide showing GBIF records of biomass in Oceania, and it's a really rich area of the world. And unfortunately, IPBES and IUCN reports indicate that this biodiversity stock is declining. So yeah, it's a really important area for biodiversity. And it's also important to note that environmental or biodiversity change in Oceania has impact not just locally, so not just in the countries and the regions, but also globally through this concept of ecological teleconnections. If you're interested in that concept, there's a nice paper there on the screen. So it's important to point out that systematically collected regional environmental data, including from some of these unrepresented areas of the Pacific, is essential to understanding broader global processes. So we've done some thinking around some potential activities and outcomes, and we've structured that around 2 phases to potentially set up this network. So that the initial phase, phase 1, would be around strengthening those soft connections, so those people connections via something like a learning network, and these are the 5 themes that we think a learning network could comprise of. So people, equipment, data, systems, and then uses and impact. And then a potential phase 2 could be around gap identification and trying to prioritize some activities to fill those gaps. So we've also done some thinking around the challenges and key considerations in scoping an Oceania bond. It's obviously hard. There's a lot of work that would go into this to bring multiple countries together, each with their individual needs. I mentioned the different agendas for monitoring. That's a challenge as well, to align those. Trust is also an issue that would need to be thought through, especially data sovereignty, IP, those sorts of issues. Of course, social and political issues, people obstacles. There's a real issue at the moment in Oceania where you have people giving up good government jobs to go and pick fruit in Australia. So those sorts of issues need to be thought through as well. Funding, of course. And then I'd just like to highlight this concept of care, because I do really think it's important when we look to Earth observation data, and we really need to ensure those links between the Earth observation and the people on the ground and the sites on the ground, those in situ sites and the people living there needs to be really cared for. Where do we start? Hopefully that's where this piece of work is helping. So what's happened and what's next? Some of this thinking started in 2019 with an Osborne scoping paper. It was then been broadened recently, and we've had some meetings in Australia to start with. We've met with the Australian Government Department of Foreign Affairs and Trade, and they've shown particular interest in this. I guess it's important to emphasize through those discussions, though, that they have emphasized that piece around the SDGs and making sure that any observation network in the biodiversity or environmental space also considers the people on the ground, those social aspects as well. We then expanded to have some meetings across the Pacific, across the Oceania region, with groups like Manaki Whenua in New Zealand and the South Pacific Community Group. We've presented to the Geo-Pacific Advisory Group, PIAG, recently, and they've been really interested in the process. So this is this what-if call, and the call for anyone out there who's interested in thinking about this further. I don't know if you've seen anyone from the Oceania region beyond Australia and New Zealand here, but if you have, let me know. I'd be really interested in connecting with them. So what's next? Well, we don't really know. So there's maybe something at GeoWeek around this. We're preparing a position paper, discussion paper, that we'd love to share with you, some future meetings, some discussions around funding. But yeah, look, there's no solid next steps for us. So if you are interested in connecting, talking to me about this, if you know something that's happened in the past or something that's already happening in this region, let me know. I'd love to hear about it. So thanks very much.
Thank you very much, Mark. Is there some question? So you made a great talk to answer all of them. Maybe, hey, yeah.
Thank you for nice talk, and it is really challenging, but very important if you can have a good oceanic network and Oceania bond. And in the case of most islands in Pacific, I think most of the focus on marine ecosystems, but of course you have a very good mountains and the terrestrial systems. So what is the recognition of each country for the ecosystem management or conservation in terms of the relative importance of land and ocean?
Yeah, 100%. That's a good point. And you notice in that slide around the priority areas, agriculture was a key one, and especially marine agriculture, so fisheries. So that is a key element of this as well. And we're hoping to connect with some of the groups doing the coastal monitoring. We haven't really expanded our thinking into the marine area, but definitely coastal. We've got some fantastic data sets that we're compiling from Australia and New Zealand, and then some Pacific islands, especially the French territories, looking at coastal data sets, so sea level rise data sets, tidal zone data sets. So I guess the terrestrial and then the coastal would be the focus to start with, and then look, yeah, if we could move into marine as well, that would be amazing.
Thank you.
Thank you. And I have a question. As you thought about what bond and what can a bond bring in the story, what is the main added value of a bond in such a system?
Yeah, that's an excellent question. And for me, I would say two things. It's the collaboration and the networking. I think that a previous speaker highlighted that as a key priority for their network. So that's one. But I think also this piece around methods and standardization. I think that's an element that a geobond can bring to this region that's really important. And so there's been some great work done in the region already. It's just about sharing that information and seeing what can be done if we work together and pull in the same direction.
And is there some particular tools that will have helped you or that can help you to do this particular work of connecting people and experiences?
Yeah, I think so. I mean, we've been looking around and talking to the Bon in the Box people and various people and around that. But I think this concept of this learning network, at least to start with, is something that I think is really powerful. So step by step, I think it's about this phase of just bringing people together. I think there's already good collaboration across some of the different regions in the Pacific. Through that Pacific community group that I mentioned before, but just then expanding that out to some of the other regions, the less represented regions, say in Melanesia, and then maybe Australia and New Zealand aren't as well connected as they should be as well.
Okay. Another question, sir?
Thank you very much, Mark, for your quite comprehensive design or ideas for the upcoming activities to build up this community. And 2 points, maybe not the question, but rather kind of just a message for the father corporation that I know that in the Pacific Islands are very much eager to have a network with the international organizations or international network to have collaborative activities or for the capacity development. And as you mentioned on your slides in the final part, you are now utilizing the mechanisms of the GEO, and including the Pacific Islands PIAG, then that is a very good idea. And we know that we are sharing this also the mechanisms of the structure of the AOGO, so it could be very good for us maybe to have this to cooperate in that also in that mechanisms to engage people, including the scientists or local people or the governments. And thank you very much, and I hope we can have more cooperation, communication in the further.
Thanks Hiroyuki-san, and looking forward to your support and the support of the AP-BON regional network, which has been, I guess, a model for us to move forward in some of this work. They really do some great things, and yeah, look, it will make it easier to expand through that AP-BON network, but also, as Hiroyuki-san mentioned, some of the platforms that the GEO group has set up. So yeah, thank you.
Thank you very much. I don't see another question. Thank you. And our last presenter in this session is Courtney Price, and she will present the Arctic Bond, another challenging area.
Hi, everybody. My name is Courtney Price. I realize I am standing between you and lunch, so I will make this snappy. I'm here. I'm from the Conservation of Arctic Flora and Fauna. That is an international secretariat based in Iceland. And I'm presenting an update on the Arctic Bond, also known in our world as the Circumpolar Biodiversity Monitoring Program, or CBMP. And I'm here representing literally hundreds of collaborators from across the Arctic and the world. And I'm going to present some pretty high-level insights that we recently learned from a publication that we made on a 20-year retrospective, looking back on the development of our network. So we're a little old in terms of bond standards, maybe. So I think it's important to situate the CBMP. We are in the structure of the Arctic Council. And so the Arctic Council is the leading intergovernmental forum that promotes cooperation in the Arctic, and it's comprised of 8 Arctic states and 6 permanent participant organizations that represent the indigenous peoples of the North. We also have the benefit of involvement from several observer states and organizations. And the bulk of work done at the Arctic Council is done through 6 working groups. And I work for the Secretariat of CAF, one of the 6 working groups. It's the Biodiversity Working Group of the Arctic Council. So CAF's mandate is to address the conservation of Arctic biodiversity and communicate our findings to the governments and residents of the Arctic, which help promote practices to ensure the sustainability of the Arctic's living resources. And our program of work is centered around these 6 themes. And we undertake various activities in expert groups, monitoring activities, assessment strategies, data information, and generation. And you can see here the borders that we designate for ourselves. This is a geopolitical border. It doesn't necessarily reflect ecological borders, so some of our projects may extend beyond this border. The CBMP is CAF's cornerstone program. It is the result of a call to action after the publication of the 2004 Arctic Climate Impact Assessment, which really alerted the world to the devastating amount of changes that were being seen in the Arctic region already more than 20 years ago. And so we were charged under the Arctic Council to develop a monitoring program. Now, monitoring in the Arctic, as you can guess, is really resource intensive. It's expensive, it's seasonal, it's inaccessible, it's hard to get to, extensive permitting processes. So we learned very quickly that we had to rely on all the massive amounts of work that were already taking place in the Arctic region. So it was built on a networks of networks approach to try to harness all the value that was of the work that was already being produced. And so through the commitment under the Arctic Council structure, Arctic states launched the CBMP, and it follows this sort of adaptive management approach. We organize ourselves across different ecosystems, marine, freshwater, terrestrial, and coastal. They generate data, which feeds into an assessment program, which we communicate. We get new insights, develop new questions, and the cycle continues. And so one central activity that launched our efforts was the development of coordinated circumpolar monitoring plans. And these represent expert consensus on what, where, and how to monitor. And then a suite of assessment reports, which are the state of the Arctic biodiversity reports. And so we report on the key elements in the system and also make statements about the level of monitoring that is happening on those key elements in the system so we can provide further advice to inform monitoring efforts. And then, of course, we provide this information into various global efforts, including GBIF and OBIS. So this is the structure of the CBMP. The various ecosystem groups either organize themselves in national networks, like you see the freshwater and the coastal group here, or into international membership on a subject matter expertise level. And so these results are fed into the Arctic Council process, and the Arctic Council acknowledges the findings in various declarations at the ministerial level, and it instructs CAF to follow up. But each one of these expert network boxes, it's a little misleading to just have it be a simple box, because there's literally hundreds of organizations and people behind each of those boxes. This is just, I think, the Canadian and Swedish involvement in the freshwater group alone. So it really is a networks of networks approach. So here, I'd like to roughly trace the process that we undertook to develop those plans and assessment reports. So after the project received support from the CAF Management Board, it moved into an implementation phase. And each CBMP ecosystem group brought together dozens of experts in a series of kickoff workshops. And so those workshops, during the meetings, they developed consensus on what questions they wanted the monitoring programs to answer. They drafted extensive concept maps, and they agreed upon targets for monitoring. In our world, this was a time before EBVs, so we called these focal ecosystem components, And they're largely species or species groups or processes that are prioritized at a circumpolar level for various reasons. They could be that they have a circumpolar distribution, or they're sensitive to change. They may be keystone species or culturally important resources. And it also may be that there's already a history of monitoring in existence for these targets. So then the experts agreed on what attributes and parameters you need to collect and measure in order to report on change in those focal ecosystem components. And this may be things that are a little bit more familiar in the EBV language, like abundance or distribution, life history events, body condition, things like this. But also, as we got better at including indigenous knowledge into this process, parameters opened up a little bit, and we became more open-minded about different measurings, different opportunities to measure using indigenous knowledge resources. So these identified things like taste, smell, changes in harvest practices. Those sorts of things can tell you about change in the focal ecosystem components as well. So these plans took several years to finalize, anywhere from 1 to 4. And so while this was happening, we needed to prove to the decision makers that we were fully functional and delivering results already. And so we developed a suite of indicator reports. And you may be familiar with the Arctic Species Trend Index, which is the Arctic component of the Living Planet Index. We also took a look at protected areas, migratory birds, land cover change using remote data sources. So those were published throughout as we were developing these coordinated plans. So then the real fun began. The groups went back to their respective countries and organizations, and they aggregated all the data and information that they could find on those particular targets of monitoring. And these were brought forth in more workshops. And the experts shared their information, discussed their results, conducted some analysis and writing, and the results were reported into CAF. And we completed the state of the Arctic biodiversity reports for 3 of the 4 groups so far. These are both Arctic Council reports, and as we developed the program, we realized the utility of making the results available in the scientific literature as well. So there are special issue journals, so they are complementary products in 2 different venues. So these reports took, on average, 7 years to produce. So once this baseline is established, though, we've been much better at being able to revisit it because we've built the frameworks for ourselves. So we are able to provide quicker, snappier results. So that will shorten the time between a detection on the ground and information submitted into policy and decision-making structures. So this design process actually was the one that informed the development of GeoBond's 9-stage development process. And I'd like to acknowledge Mike Gill in this work because he was the CBMP co-chair and he came to GeoBond right after. So I think a lot of the lessons we learned at the CBMP are already embedded into GeoBond processes. So I'll take a look at the terrestrial plan here. So these are the focal ecosystem components that are the targets of monitoring that the terrestrial group recommended. And they're based in these 4 categories, but there are subcategories under each. So in vegetation, it is species assemblages, rare species, food species, and non-native species. And in arthropods, it's blood-feeding insects, decomposers, pollinators, prey for vertebrates, herbivores, parasites. And in the birds, different feeding guilds, so herbivores, insectivores, carnivores, and omnivores. And in the mammals, it's predators and herbivores, small, medium, and large. And so we were able to report on most, but not all of these things. But I think what might be more interesting for people here today is what we had to say about the levels of monitoring in these particular focal ecosystem components. So these wheels represent the status of monitoring across the Arctic for those terrestrial focal ecosystem components that were identified in the plan. And what really stands out is all the red in the arthropods. It's probably no surprise to anybody that these are chronically under-monitored components of the environment. Aside from Greenland, so congrats to Greenland there, because they managed to have consistent funding for long-term monitoring, but in very poor spatial coverage of Greenland. So this story is really the Zackenberg Research Station. So that was an important data gap that we acknowledged at the publication of the report. And since there's been an Arctic pollinator network that has developed to try and address some of this gap. But there's also other surprising results as well, particularly the amount of bird and mammal species that have purple dots. Purple dots here represent poor spatial coverage and sporadic funding. These are more of the charismatic megafauna you might anticipate being well covered, but it's very hard to ensure consistent coverage of some of these components in the Arctic environment. So it acknowledges the work that's underway, but it also helps us identify the challenges that we still have and we still need to rise to in order to meet the information needs. So because these findings are embedded in a governance structure, there is some acknowledgement that there needs to be some follow-up. So the CBMP as a whole is also developing products that can increase the access to the advice and information that is arising from the program. We're in the process of developing an Arctic biodiversity monitoring toolkit, which will be an online space where interested people and practitioners can go to download the monitoring advice that the CBMP has gathered on the particular topics. It's also a place where the CBMP experts can go to more quickly update their advice instead of, creating a report, going into this structure, needing approval. So this was intended to be a snappier type of product. Each ecosystem group is also collecting and compiling knowledge maps or metadata so that we can provide information into other global processes, things like the GBF or the Central Arctic Ocean, which is developing a scientific and monitoring program. So we'll be able to tell them what's already there in terms of monitoring efforts. And results are available or will be available on the Arctic Biodiversity Data Service, and that of course connects with GBIF and OPIS. And we're also working with NatureServe on building an Arctic biodiversity dashboard, which will better display the results that are coming out of the CBMP. Okay, almost done. So earlier this year, we published the 20-year retrospective, so I'll just take you through some of the lessons that we've learned there. And it's really, do not underestimate the need for coordination and the difficulty in getting funding for coordination in particular, which brings me to my next point, funding. We've heard from others here today that funding is a challenge and it remains a challenge. Arctic countries are some of the wealthiest in the world and we still face this problem consistently. There's also the need to improve your standards and protocols, a co-production of knowledge. So by this I mean the bringing together of Western science and indigenous knowledge at an equitable and ethical engagement process is really essential, and we heard from our speaker yesterday about why that is the case, and particularly in the field of biodiversity. Data management is integral. You need that in order to make your regional analysis and comparisons across efforts. And you need to ensure that resources are there to engage in international fora such as this and such as the CBD to ensure that your programs are being implemented, but also you're having effect beyond your own region. So, as a result, some advice for others. Be creative, be flexible as you develop your networks. Start small, maintain your focus, and build on your success. Prioritize your activities. Keep your structures simple. Make sure that you have an internal organization that is effective and not burdensome. Build on the existing monitoring capacity and information. Be adaptable when you're developing your monitoring program at an international scale. Plan and budget for data management, analysis, and coordination. Be relevant. Link to your reporting mandates for your partners. Involve decision makers and funders in those conversations, and show value added for your efforts. For experts involved, participation in the CBMP has allowed for greater increased access to data, to networks, for funding. It has increased publication potential and actually provided opportunities for more monitoring. For decision makers, their participation answers questions that they have and ensures the wise investment of resources. So, these are just some of the Marine and Coastal Steering Group members. So, this was the last time we were able to physically meet with each other in 2019. We're in Greenland there. So I encourage you, please reach out. The Arctic Bond's been around for a while, but there's still lots we can learn from GeoBond, and actually I've been really impressed with a lot of the work that I've seen over the past couple days, and I'd be really interested to learn how we might be able to apply it in an Arctic context. So thank you very much.
My name is Mathieu Bazy, and I'm working for the French Biodiversity Agency. Thank you so much. For the Biodiversity Plus partnership. And in this talk, and actually the following two talks, we're going to try to present our operational view of EBVs and how we think they are important. But to start with, where do I? No, 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 no. There. There we go. I just wanted to reflect, take a step back and reflect on what I've seen so far at this conference. And I've seen that we have, on the one hand, a wealth of data that's coming from various sources and methods, either conventional, but we've seen also a bunch of things about the new methods. I'm not going into the details, but that's one thing. But at the same time, we also have broad issues when it comes to biodiversity monitoring. We have gaps, we have a fragmented landscape, and we're being too slow, basically. That's what I heard in the past few days. There were a few attempts of providing solutions, including, well, let's get first to work, real work, hard work. But there was calls for coordination, collaboration, sharing, those kind of things. There was also a suggestion of community-based monitoring and a whole bunch of other solutions. But what kind of struck me, or maybe I was not in the right sessions, but overall was, and I still don't know where I need to click. Okay, does this work? Yeah, the green one, yeah. No, it doesn't. The green light just bleeps, but it does nothing.
Yeah, this button responds, but the page doesn't change.
Okay, can you press the space bar whenever I do this? Can try. Ah, there we go. So one thing I kind of been missing, and maybe I was not in the right places, is a discussion about the monitoring, biodiversity monitoring community, about GeoBond and what brings us together here. And so I wanted to follow up with what once was at least the poster child of GeoBond, EBVs. And here in this presentation, I'm going to go a little bit faster on some things that I thought were important, but after 3 days, I think I'll spend more time on why we think EBVs are important. It works perfectly, thanks. I call them the elephant in the room because this is really something that GeoBond has been developing and pushing forward, but I haven't seen many talks really connecting their work to the EBV framework. So in a nutshell, what are EBVs? Well, I hope that most of you at least know what they've been how they've been defined. They've been defined as the elementary information units about changes and trends of biodiversity. And they are presented as an intermediate level in between raw data and broad-scale indicators as this aggregation that forms information at a proper scale for biodiversity monitoring. And you've probably seen that also many times. They're organized in 6 classes, 3 that are associated to the ecosystem level, 3 that are associated to the species level. I'm just checking behind. I think it's big enough for everybody. That's good. And there's actually 21 EBVs, and I'm not going to cover all of them. Just wanted to mention that it goes from very broad ecosystem structure, EBVs such as life cover fraction, for instance, or primary productivity, all the way down to very specific genetic information like inbreeding or genetic diversity. So there's a whole bunch of them. And if you've followed the same path as I did, trying to learning and understanding EBVs, once you've been there, you probably ask yourself, okay, now what? It seems very fuzzy and not very applicable to real world. So today I want to offer the idea that EBVs actually offer a common language for biodiversity monitoring, a common language that we can use, really use from different perspectives. So let's take a step back again. Why do we monitor biodiversity? So I stole the title of this conference, Monitoring Biodiversity for Action. Basically, we can think of 3 main goals about biodiversity monitoring. The first one being evaluating the state of conservation of species, ecosystem, habitats, you name it. The second one would be communication, to raise awareness of both the public and deciders. And the third one would be to actually act upon something that's management of, again, ecosystems, species, habitats, you name it. Well, our point is that actually EBVs offer this intermediate level that is a common language to reach all these 3 goals with a bottom-up approach coming from what we're actually doing in the field, what are the monitoring schemes in the field, what are the actual data and information we're producing already in the field. But also you notice now that arrows go both ways. That is, we can use EBVs to formulate the needs for evaluation, communication, and management in terms of EBVs as well. So that's, I mean, if there's one slide to remember about my talk, that would be this one. So to make them operational, there's been the idea of developing a grammar. It's a language after all, so to have something, a bit of a structured language, we need this grammar. This grammar, it revolves around 4 fundamental questions, which are basically when, which, what, and where, to define when the temporal definition of what we're looking at, which the biological level, what the EBV, and where the spatial definition. If you get all these 4, you get what your Pabon has called fully specified EBVs. So a little bit of detail. Temporal definition, this is a very classic thing that covers time span, grain, trend, the trend in terms of what can you get out of it over maybe 1, 10, 20 years, or over sliding windows. Biological level is typically species ecosystem, as we've seen before. The EBV is really the metric, but now you can define it precisely with a unit, or if it's a relative or if it's an index, might be just unitless. And that's where the spatial definition comes in, extent, grain, resolution, nothing very fancy here either. The good thing is that we're trying to rely on reference systems as much as possible to define to answer those 4 questions. And for instance, for the temporal dimension, we can use reporting systems. For instance, in the EU, it's very common to have reporting every 6 years. So can we produce, or do we have trends over 6 years? That's a good reference system. On the biological level, that's simply taxonomy. On EBVs, that's the 21 EBVs and 6 classes we've seen before. And for the spatial dimension, we have plenty of geographic, administrative reference systems as well that we can use to sort out the EBVs that we're using. I'm going to now go with 3 examples, trying to make this a little bit more concrete with what we mean with the EBV grammar. First one is about brown bear monitoring in France and Spain across the Pyrenees mountains. So you can ask the question about what do we know? Well, we know, for instance, the trend of brown bear distribution within the Pyrenees mountains, or the abundance as well. But we know also the effective population size in the Pyrenees mountains. That's the scale of the mountains, or inbreeding as well. If you make that kind of sentence, you can consider this as kind of the spoken form of the grammar. This is very an interesting form to communicate, to define in human terms what we're talking about, to share information. But there's also a very low-level written form where you have to actually define those things. For instance, brown bear monitoring happens since 1995 till now, every year. So that means you can also compute trends over 6, 10, 24 years, for instance. The which is just a Latin name, scientific name of brown bear. And the what is the 4 metrics that we can use that are associated to EBVs. And you see that some of them have a unit, and inbreeding does not. It's just a coefficient. And the where, you can see that the first 2 are graded with cells of 10 square kilometers. The last 2 are just one number for the whole range, the whole Pyrenees. So that's very much of the specification of the EBVs that we have. And so you notice also that it covers both what we actually have from the field, but what we can also produce from there. We do have yearly numbers, but we can produce trends just as easily. If the specification is well formed, you can derive these trends. I'm going to show you another example, which is forest trees in France. There's the French national inventory, national forest inventory, which gives us, for instance, the trend of evergreen oak distribution within France, or again, another one which would be morphology. I took just one species as an example, but we know also EBVs that relate to community composition, such as taxonomic diversity of temperate periodic sclerophyll forest, which is Mediterranean forest, basically within France. We know also, even at ecosystem level, the trend of forest cover based on the same monitoring scheme, which goes from 1958 until now, use sliding windows of 5 years, et cetera, et cetera. Again, we have defined those EBVs. For instance, morphology is trunk diameter, which is measured in centimeters. And the whole of France is actually graded, again, over 10 by 10 kilometers square to give us these outputs. And the last one, even more broadly, is the NDVI, which comes from satellite remote sensing. And with this, we can know the trend of wetland primary productivity within Europe, for instance. I'm not going to go into the details, but that's just to show you that the grammar can apply to very specific, narrow, in a sense, monitoring schemes to very broad monitoring schemes that use remote sensing. Very briefly, I see the time, the clock ticking. Here are the 4 questions. We wanted also to associate a 5th one, which is how good is this EBV results, which is all about quality control. And to get to that, you need to understand the how was this whole thing produced. I'm not going into the details, but that's all the metadata that comes into play, starting with the identity of a monitoring scheme, who is actually doing it in the field, what's the sampling protocol, where do we actually collect the data, the field protocol with a bunch of hows, and of course the analysis, which is the production pipeline. So this is still very much work in progress. The idea would be to really have the answer of how good the EBV's product are, so that is quality control. And just in a nutshell, my conclusion, if you need to remember something, never forget EBVs are great. And they're great for a couple of reasons. The first one is they're very modular. Once you get to that elementary units of knowledge, you can use them directly as they are, but you can also combine them into something bigger, larger, longer, whatever you want. You can also synthesize them into something simpler as an indicator. But the good thing, and you're going to learn a whole lot about that in a couple of presentations, is about collaboration as well. It allows harmonization without even modifying existing monitoring schemes. So don't touch what you're doing in the ground. Just produce EBVs, and then we can talk, we can compare things together. And finally, and this is going to be the topic of the next presentation as well, this allows this common language to have a standard information system. And I'm just a few seconds late. Merci beaucoup. Thanks very much for your attention. Hope this was as good as coffee, which we all need. And we didn't say we're going to go with these 3 talks at once and get questions for these 3 at the end of them. Thank you very much.
Thank you very much, Matthew, and keep your questions. We will have time for them after these 3 talks by French colleagues. So next one is Guillaume, have a floor. And he's going to tell us about EBVs facilitate international cooperation and harmonization. Correct?
No.
Okay. Then another one, let's try influence of the EBV framework on biodiversity monitoring systems and services.
Can I have the slide, please? Yeah. So in between, so I'm Guillaume Body. I'm working for the French Biodiversity Agency for Biodiversa Plus, the European consortium on biodiversity, and for the National Museum of Natural History in a common unit that is Patrinet. And I'm going to present you all this concept of EBVs that Mathieu presented influence the services and the information system that we have in France. So I told you that Patrinet is a common unit between the Natural Museum and the French Biodiversity Agency, and it manages the information system on biodiversity of France, which is linked to public policies. It also manages the National Center for Data on Biodiversity, which is more linked to research. Altogether, they form the French BON. But we are also setting up for the ministry the terrestrial biodiversity monitoring program, and other colleagues in the agency are managing with other ministries and agencies the freshwater and the marine monitoring program. So we are really as strategists to plan monitoring in France and also in Europe with Biodiversa Plus. So we have services and information system to be able to manage that. Maybe the first one is the SCNP in Orange. It's basically a database that can manage data and is connected to JBIF. And with that, we are able to be, I think, the second provider of JBIF in terms of raw data of occurrence. We have website for the natural inventory, for aware public, and we have another website, Nature France, for general public. Another service is the National Biodiversity Observatory that aims to provide indicators and to develop indicators of biodiversity for general public and politics. And we have also something we are not often referring to, but we have a center to administrate referential lists in France, which are really important for information systems. And yeah, that's a bit of what is monitoring. In France, there are a lot of different elements to monitor on marine, freshwater, terrestrial, a lot of different techniques with new technologies, but also dog helping us. We are monitoring from ground, from air, from boats, submarine, with citizens, with researchers, with a lot of different people and activities. And my purpose is to have an overview of around all of that. And how do I do that? So the question came when we tried to set up the terrestrial biodiversity monitoring program for France. And there was a lot of questions. What should we monitor? What do we monitor for? What is the action expected from that? At which scale do we monitor? We have the national scale, but there is also subnational scale or international scale. What is the biodiversity that is being monitoring? Who is doing the monitoring? How much does that cost? Where are the data and where are the outputs? And maybe another question is, how is this information shared with our neighbor, Germany, Spain, Finland, and the whole world? And EBVs start to give us some answer. So what should be monitored? Species and ecosystem. We added habitat, which is just smaller grain ecosystems, because we needed to. What's the biodiversity being monitored? We can answer with EBVs. And we have information about what do we monitor for, who is doing the monitoring. We know that estimating the cost is very hard. There are plenty of people doing that. The data are stored in different places, institutional, national, and global database. And the monitoring outputs can be found in reports and science paper, which mean PDF, which is, I think, a pity. And the whole information cannot be found. It's very, very hard to find all of that. In France, we just identify for the terrestrial monitoring program 200 schemas, and it's just a part of it. It's where I needed a tool to be able to aggregate and find all of this information, and that's where BioDash is coming, a dashboard of monitoring schemas. I want a tool that will help me to synthesize and to connect the different schemas, to match the producer and the users, to connect people and to acknowledge their work. I'm not doing the work myself, they are doing the work, and I must put them into light. I must involve founders, because that's a key element. I need to help people to navigate through repositories, and another question arises from that is to describe how the monitoring is being performed to assess its quality, which is a key element. And we are going, forgot to say, we are going to develop such a tool with Biodiversa Plus at the European scale. And this tool is based on the concept of the fully specified EBVs, the variation of a biological entity variable in a geographical scale. And I have backbone for each information. The variation, it could be temporal, spatial, or spatiotemporal. The biological entity, its species or ecosystem, and I have a list for that. The variables, they are EBVs, where EBVs come from. And the geographical scale, I have administrative reference lists, protected areas reference lists. I have plenty of lists, but there are lists, so that's good. I can define all my product, basically what the monitoring schemas is producing as information to try to manage the whole system. And this unitary results of monitoring schemas and these 4 questions are also interesting questions. What kind of variation do we need? Do we need spatial or temporal variation? It's not the same schemas that will handle with that. For which entity and which variable do we really need, and at which spatial scale? Maybe it's global, maybe there is a need for global, but there is often ground-based and small community-based information that is really needed. So we can connect the policies and the information requested. We can link the request, as I said, and the production with the same grammar. I can describe what the European bird directives wants. I can describe red list requirements to be able to perform their job and assess the status of species. And I can, on the other side, have one monitoring scheme and describe what it's able to produce, and then I can see if it matches or not, or what is a partial match, and I can see that it takes a few monitoring schemes to answer one request. I can have also synthesis. Don't try to read that's true. That's the 400 bird species we have in France. I listed all of them because I have the reference list. On the bottom, it's EBVs. So the first one is abundance. The other one is distribution. And I can see what I'm monitoring in France across the different schemes. I just remove the name of the schemes and just target the information they are producing. I can see also on the complete right that I have species that I'm not monitoring. Is that good or bad? That's another question. At least I have the information. And I can also see that I have more information about the temporal variation of the abundance than on the distribution. So my main information I'm getting is just temporal trends, graphics, and not maps. That's another way of synthesizing the information. If I have information about the status of species and their reglementation, I can know how many protected species I'm monitoring according to the number of protected species, the number of hunting species, the invasive alien species, the species that are threatened or not threatened, and the species that are in European directives. And that give me a tool to manage my system. We can also work on the outputs and to harmonize outputs that are EBVs, that are temporal trends. It's actually a bird abundance temporal trend, but it could be anything else. All the graphic will look like that, and it will be interesting to harmonize the smooth trend, to have better communication, to harmonize also the linear trends that we need for red list, for instance. It's linear trends that we need on specific scales. And we can harmonize all of the production from the different monitoring schemes. I can also work on reorganizing my workflows. Currently, each monitoring scheme is trying to answer to each request, and each team that is performing indicators or assessing red lists try to reach each monitoring programs. And if I had a new request on that had me as many arrows as there is monitoring schemas, and the coefficient is just exponential of the number of workflow we can have. Using EBVs in middle, using the capacity of EBVs to be in between row and indicators, I can have well-organized workflow between the monitoring schemas and EBVs. I store the EBVs, and then any request can go to the EBVs and not to the monitoring schemas and get the information they request to do their own job. And if I had a new request, I don't have to go back to my monitoring teams, and they will be happy about that. So to perform all this work, which is work in progress, and it's a slow process to change administrative procedure and the way people are working, we ended up saying that we need a new database. Currently, we have the database on the left, which is raw data connected to JBIF, sending a lot of occurrences. We have the database on the right about indicators and connected to public policies. but we need the one in between, which represent EBVs, and we need to standardize the outputs, so we need to standardize the EBV data product. We also need a tool to visualize this kind of information, which is really precise because it's species per species, variable per variable, and ecosystem per ecosystem. But doing so, it's just coming back to the fundamental of EBVs, and you have on the bottom right the original representation of EBVs by Simon Ferrier with the 3 different steps and the white arrows representing modelization, so you modelize raw data to EBVs, EBVs to indicators. And we are just implementing this view, and with the concept of fully specified EBVs, we are able to perform this implementation. And I just don't know why on a GeoBond web page to present EBVs, this schema has disappeared. So thank you very much. And we switch to the other.
Okay, thank you, Guillaume, for this presentation. And everybody will stay still at least the next presentation. So we go to the Michelle, and you will present that one also. And then we have joint time to discuss about these first 3 presentations.
It should be a recorded presentation.
Yeah. Okay. Can you find the recording there?
About the essential biodiversity variables and show how they can facilitate international cooperation and harmonization. Because of the diversity of the different monitoring objectives and targets, for example, the different species that are monitored, the programs are also very diverse in terms of scale and range covered. And of course, there is a vast array of different techniques, methods, and field protocols that are used. Now, on top of that, there is a variety of contexts, such as historical and cultural differences. We can see that, for example, that the presence of a volunteer community for monitoring is not always a given in every country. The monitoring programs depend also on the means available, both human and economic means, and the type of institutions carrying them out, whether it's NGOs, universities, government institutions. And of course, there is also the diversity in biogeographical contexts that play a major role in monitoring. So we can ask ourselves within this diversity of contexts, how could we monitor biodiversity across scales in a harmonized way so that we can see the wider picture? And this is a question that we've been working on at Biodiversa Plus, the European Biodiversity Partnership. And one of Biodiversa Plus's objectives is to promote and support transnational biodiversity monitoring. And within this framework, we are studying the possible strategies for an optimal harmonization of monitoring protocols, methods, and databases. And today, we're going to focus on the harmonization of protocols. And for this, our first step was to analyze what is already being done in terms of transnational monitoring, and most importantly, to try to understand how. So we carried out a literature survey on transnational biodiversity monitoring programs. And we can tell you that there is a great number of them. And we chose 15 case studies to really focus more in detail and to see the program's objective, its governance, so to see how it's organized and who is involved mainly, the type of protocol that is employed, the geographical scale at which the biodiversity information is collected and aggregated, whether it's local, national, or regional, and then the form in which the information is transferred for decision making, whether it's transferred as raw data, EBVs, or indicators. And well, it's no surprise, the results showed that there are different strategies that are used in the different monitoring programs. And it seems that the strategies depend on two main components. So firstly, there is the flexibility of the protocol, as some programs opt for a strict protocol that is carried out equally throughout the entire territory that is covered by the program. Then on the other extreme, there are programs that rely on results coming from different protocols. And in between, there are programs where there is one general protocol that is applied in a flexible way. This way, it is more adapted to local conditions, mainly. Now, the other main component is the data aggregation and transfer in the information chain. So the first possibility is to collect data locally and then directly analyze it at the transnational scale in order to produce the general indicators. Then there is another approach where the data is collected and treated locally to produce EBVs, for example, and then it is at a transnational level where the different EBVs produced at the local scales are aggregated to produce the general indicators. And finally, there is a parallel approach that seems to be promising, where there's both the raw data and EBVs that are transferred to this transnational scale. And this approach is being tested by some pilot projects, so we'll hear more about that in the future. Now, when we look at both of these components together, on the one side, we have the protocol flexibility gradient that you see up there. And on the other, the scale of data aggregation and processing. So different combinations are possible. And from our literature survey and analysis, there are three main combinations or strategies that appear to be used the most by transnational monitoring programs. And of course, each of these have their pros and cons. So on one side, on the top left, there are programs applying one strict protocol and gathering the raw data for a joint analysis at the transnational scale directly. And this way, the results are easy to compare, and the implementation of the monitoring protocol seems to be quite easy, as it's a straightforward, strictly defined protocol. But the strategy is inflexible to adapt to local priorities, which might not always align with the defined protocols or what is wanted from these monitoring efforts. And because of this distance to the local priorities and involvement, this might lead to a lack of motivation of local stakeholders. Now, if we look at the other extremes, or at the bottom right, there is a strategy based on the use of EBVs, which are produced locally, for example, at the national level. Each country would apply the protocol of their choice in order to produce the defined EBV, or the EBV that is asked for this monitoring. And then the EBVs that are produced in different countries are assembled to have a transnational overview. Some of the main benefits of this strategy are that by using the existing protocols, previous work and knowledge can be leveraged, and the old data sets aren't lost. And as well, redundancy in monitoring efforts can be avoided. Also, local initiatives are reinforced and integrated into this wider community, which can boost motivation and the sense of ownership. Nevertheless, there are also challenges related to the need for this higher scale coordination, and the fact of defining and agreeing on the EBV metrics to follow would require significant effort as well. Finally, here in the middle, there is an intermediate point combining both strategies by using the country-specific variation of a common protocol and the parallel data flow in the information chain. Here, the use of local knowledge and validation in this approach satisfies both local and global requirements. And this flexible approach offers different options that can match the different levels of expertise available locally also. And it facilitates the integration of new tech into the data collection and analysis, as they can be added as possible options of techniques used in a given protocol. Now, on the downside, the strategy can be costly and time-consuming because you have to handle both raw data sets and EBVs. Now, our main outcomes and recommendations based on the analysis would be that regarding the protocol's flexibility, it really depends on the situation and the starting point, whether there is an already good monitoring coverage by ongoing programs or not, or if you have to start from zero. And now, regarding the data workflow, it would seem beneficial to maintain a parallel approach, where both raw data and EBVs are analyzed at the transnational scale. Now, to focus on one of our recommendations, that would be having a parallel transfer of data where both EBVs and raw data are shared to the transnational scale for the analysis. We will explain here a bit more in detail the added value of using EBVs here. So the EBVs, to recap a bit, are produced at the local level. We can imagine, for example, each country is in charge of collecting and treating the data via the protocol of their choice, and then they provide this standardized outcome in the form of EBVs to a structure that is operating at an upper scale and that assembles all of these EBVs produced in different countries in order to have this transnational view. Here, EBVs facilitate the comparability and interoperability of monitoring products, and they allow for a common language. All of this while leaving the current practices on the ground as they are. So let's say the field protocols can be left untouched. And there is also a sense of subsidiarity and the prevention of possible conflict among stakeholders, because all of these stakeholders will be aligned into a network, so there is more dialogue and more cooperation between people as well. And now, why do we talk about monitoring communities? This is related to the fact that depending on the monitoring community, let's say the bat monitoring community or the marine biodiversity monitoring community, or there's any number of communities. So depending on the monitoring community, the EBVs that are relevant to follow might be different. So there needs to be an agreement within each community on which EBVs can be produced and aggregated to have this transnational picture. Now, following this idea, there are many governance implications for the functioning of such a system. And we would like to propose a common framework where the results from different biodiversity monitoring communities can be integrated effectively. So here we can imagine, for example, different biodiversity monitoring communities. Here, 3 examples. We have the soil biodiversity community here in green, the bird community in dark blue, and the freshwater ecosystems in light blue. There could be a long-term community node ensuring the general coherence, coordination, and facilitation among the different stakeholders involved within each monitoring community. And as well, there could be a technical expert group which will work more precisely on defining the EBV values for this community and the possible protocols designs and the statistical analysis for it. And now to ensure the general coherence between the different communities and the EBVs and monitoring programs that are produced by each community, we can imagine the expert groups of each community being linked to an inter-community technical expert group. And this expert group would be part of a wider hub, so at a larger scale that is linking the biodiversity monitoring communities. We could imagine this as a regional biodiversity monitoring coordination center, for example. So now all of these results, recommendations, and this proposed framework are presented and explained more in detail in a guide that is being published by Biodiversity.
So I will just end the sentence. The last slide and the report will be published by Biodiversa Plus at the end of this month.
Okay, thanks for this information. So I think that was it.
Yeah.
Okay, and now we have time, 5 minutes for questions for these 3 EBV-related presentations, if there are any questions in the audience. Who would like to start? Oh, there. Good.
Yeah, well, it was great to see. I kind of been following a little bit, but it's great to see you all. I had a question, kind of that EBB could serve as this common language, and it's fine, I agree with that, but this part of not touching the monitoring in the ground, I think that the effort that you have to do to produce EBVs that are compatible with different methods and source without not touching this or harmonizing some type of data collection protocol. I don't know if you can explain a little bit more of that, because I see it quite challenging.
So let's take an example. We are managing French bird at the French scale. We have a monitoring that is well developed, well applied, and running for 50 years. If I have to break this series to have a common European monitoring, to have better European estimate, it's decreasing my own monitoring schemas, and it's decreasing the estimation that is directly linked to the policies, because the policies are more at the national scale than at the European scale. And what will happen is then that the birds are also flying in Africa, so when I harmonize in Europe, I also have to harmonize between Europe and Africa, and then to harmonize with the world. So the risk is to break the series multiple number of times. So that's a risk. There is also advantages to do that. I'm not saying we should not do that. It's just there is different ways. If the different communities find a good way to harmonize their protocol and it works for their own needs, let's do that. Because the communities and ground base want this kind of information. If it's just coming from top, saying it's easier to have global estimates if everything is harmonized, it's true, but it will not take, it will not work at the local scale where it matters. So basically, we should harmonize at the scale it matters, where there are policies. And if in this conference, there was a lot of talks about community-based monitoring. It's important for them because they feel engaged, and maybe it's better for them to have a monitoring that suits them rather than applying a global protocol that they do not feel comfortable with that. So it's always a trade-off, but we have to see that as a trade-off and choose our way in between.
If I may, just to complement that, the EBV put a focus on the product, not so much on the production of the product, which is a good thing. But that's also why we've added in the last couple of slides I presented how good is that estimate, how good is that product, and we certainly need to know that if we are to compare or combine EBV products together. So that's just to complement what Guillaume said.
Yeah, just to add, the first slide of Michel that you were not able to hear was about the diversity of situation and applying the same protocol in England, where citizen science is very common, to Finland with a hard winter and Greece with a hard summer, doesn't work. just doesn't work. The same protocol, and with the insect, the pollinizer initiative, they discover that the same protocol does not work according to the different biogeographical situation. There is a diversity in the community you have, the money you have, etc., and we have to take that into account.
Yeah, there's a next question.
Thank you for your presentation. And I also asked this question in another session, and I'm running around this conference asking people how you actually, if you actually have explicit EBVs in your indicators production. And my question to you, because it seems like French-born and your users or producers or funders of data seems to be convinced of the EBVs. Theoretically, we understand that EBVs help you move towards standardization of biodiversity monitoring and indicators production and so on. But how do you see us convincing the government, different nations outside of France and other advancing countries, in the value of EBVs in getting the monitoring right and the systems in place, so we are a little bit better at understanding how the biodiversity is changing globally?
I'd say the first step is that if these governments are already convinced that they have to work transnationally, then it's already a win. The EBV is actually not so much, going through the EBV process is not so much of a burden as compared to alternatives. So if the goal, which is already agreed upon, is to collaborate transnationally, then you have to provide a set of solutions and alternatives. And it seems that the EBV one, which is still costly because you still need to do something more, right, than what's already out there. But it seems that it might be actually the easiest path to get to this transnational collaboration. Other things would be either you break down everything and you start from scratch, which is in most cases not possible, or, well, I don't know what alternatives would you have, but having this intermediate level really breaks things in a rather optimized way, I would say. Hopefully that answers a bit of your question.
If I can add, what convinced my director of that to be a good direction to move toward is that they were already producing EBVs. They didn't know that, but they were producing EBVs. And we just acknowledge and standardize what is produced and put that into life. And then, given its whole control, we can see the landscape of what we are producing and we can start to manage that. We can start to see if to have policies. Do we want this information, or do we prefer this one? Is it national or transnational, which is the priority? Is it wolf or dolphins? That quite different species, but wolf or foxes. That's different challenges, different impact on the policies, and you can link policies to the science, and policies can express a need in EBVs, and then we send this request of EBVs to scientists that will set up a monitoring system to be able to answer that. So that's communication between science and policy, and that's what are the true value of EBVs, I think.
I have two short questions. We have to go on with the program soon, but if you can answer quickly. So my question for this BioDash was that, how does it work with the ecosystem structure function? And then another question for this EBV, national EBV dashboard. If you suggest that countries will build this kind of national EBV dashboards, can they connect through some APIs then to this EBV portal what GeoBorn and IDIV have been developing already? Is that in your imagination?
I will start to answer the second before to forget it.
Yeah.
Yes, if we produce EBVs and we have EBV web portal where we can present all this information, I guess informaticians will find a way that they communicate to each other, and we can get what is produced at global scale to inform our national scale, and the opposite being true. And what was the first one?
And you were also mentioning this visualization tool, so maybe this EBV portal could be then the visualization tool if you just collect that data on your national hub where it transfers to the EBV portal.
Yeah, it's just we can merge tools and to have the same tools that can apply at global and regional and national scale.
Yeah, and your BioDash, you had only the species examples. So how about have you been thinking it through the habitat data or ecosystem function data?
You just have to change the species name by the ecosystem name, and the rest is exactly the same.
Okay, thank you. Thanks for...
And in general, Petri, technical issues are the easiest to solve.
Yes, I agree. Okay, thanks for these three presentations. And then we move on. We have a next speaker is Frank Müller-Karger, and he's coming to tell us about the marine bond latest developments. You're welcome.
Thank you, Petri, for the opportunity to talk to this group, but I feel I'm going to repeat exactly what Guillaume and Matthew just said, but with a Spanish accent. So I'm going to talk a little bit about the marine flavor of this, but it's really very good and very reassuring that we're now starting to talk the same language. Outside of this conference, I think there's still a lot of confusion about what an EBV is, or what an EOV is, or what an ECV is, and so. And I feel that we're now talking among people that we're repeating ourselves for 3 days in a row, but I will do it anyway. So I think that the point that Matthew and Guillaume just made is very good. I mean, we're doing this because we want to address societal goals, not just because of the science of it, but how do you connect to an operational framework? And I think that that's part of what we're missing. So most of the people here in this conference are researchers, and we build these research programs and collect the data to build EBVs in a research framework for a small-scale project that lasts a little amount of time, and it's not sustained over the long time. That is not really sustainable for addressing societal goals over the long term. In the ocean, we want to integrate marine life observations into a global ocean observing system that has evolved over time, over the past 30, 40 years, to measure the physical variables, temperature, salinity, density, things that are important from a weather point of view, or climate point of view, and they're also easier to measure. And ultimately, they have added biogeochemistry, so nutrients, CO2 because of the importance of ocean acidification and air-sea exchange of gases. The other thing that we have not made a lot of advance in is in data mobilization and interoperability. Everybody collects the data, stores them a different way, and there's very little data flow compared to what is collected. So there's a lot of data collected, and yet it's not moving. We want to plan for ecological forecasting, so modeling and forecasting really is the ultimate goal, is try to meet scenarios and planning and what is going to happen if we manage the energy industry or mining industry in one way, or what's going to happen with climate. And then try to coordinate between international networks so that we can understand what happens locally in a global context and pass the data from a local point of view to a broader global network. The ocean has been organizing itself for many years, the ocean community. Now we have something called the UN Decade of Ocean Science for Sustainable Development, what we call the Ocean Decade. And the decade has 10 challenges, and I'm working with a group on Ocean Decade Challenge 2, which is protect and restore ecosystem and biodiversity and try to understand multiple stressors. So part of this is harmonizing the language on how we work with the community on how we mobilize the data. Because at present, there is no coordinated effort to observe life in the sea. It's just a bunch of discoordinated, a bunch of loose efforts, and largely academic and research. So we've been trying to do this, as I said, for several decades. The Global Ocean Observing System was adopted by the United Nations under UNESCO, the Intergovernmental Oceanographic Commission, in 1991. They already agreed at that point that we needed biology in the mix and how we observe the oceans, and they didn't get around to doing it. The Census of Marine Life came around in 2000, and it lasted only 10 years. It was a privately funded effort, and it made huge advances. It created OBIS also. And that framework, the Ocean Biodiversity Information System, it still exists, and it's kind of the parallel to GBIF. And they are together working on data management standards, basically the Darwin Core and its extensions. Then that ended, and we decided to create MBON as GeoBON had formed to kind of revive those ideas and try to point to an operational framework with the Marine Biodiversity Observation Network. So this is the thematic bond of GeoBON for the marine area. And we collaborate very closely with government agencies, but also with some of the other agencies internationally. So MBON sits under GEO, but all the other things that are coordinated sit under the United Nations, and they're not necessarily connected. So we try to bind the two things and the two universes of what ends up being the same governments, but different representatives. And in 2021, we proposed to the Ocean Decade to form this program called Marine Life 2030, which is really an aggregation and a collaboration between GOOS, OBIS, and MBON to try to promote these things under the umbrella of the Ocean Decade. And there's a lot of other different programs under the decade that are trying to collaborate. So all of these partners, OBIS, MBON, the Ocean Best Practices System, also under the IOC and GOOS, are trying to mobilize what we call the Framework for Ocean Observing, which is basically, I'll try to show it here, where GOOS tries to collect the requirements at the international level and document them. So what does the CBD need? What do the Sustainable Development Goals need? So there's a number of international agreements and conventions that have requirements for information. MBON has taken the role that we take those requirements and we translate them or work with the community, with the ocean community, to try to promote networking on how we would collect things in a specific standard. We educate the community about the standards for data formatting, and then pass the data on to OBIS. So with the idea that we want to mobilize data in an open way to databases like OBIS, there's also other databases that are evolving, like the acoustics community has the imaging community. So GBIF and OBIS are not the only databases out there, and yet we need to connect these databases better. And those then those are the basic data that would move into what we would call EBVs and indicators in the end. And then we have a loop around where we want the community of users to give us back requirements and feedbacks. So very quickly, I'm going to talk to you about how we organize the community under the Global Ocean Observing System that sets these requirements. There's 3 panels under the GOOS, under the Intergovernmental Oceanographic Commission. One is on physics and climate, OOPC, one on biogeochemistry, and one on biology and ecosystems that we call BioEco panel. Then they have these essential ocean variables. The essential ocean variables were first conceived in the 2000s. They were published at the same time that Pereira et al. Published the EBV paper. So this was the first paper that had these essential ocean variables came out in 2012, so same time frame. And they're divided in principle just to organize the community by physics, biogeochemistry, and biology and ecosystem. But we need them all. So depending on which case, you can combine these things. So these are the biology and ecosystem essential ocean variables, and we have the normal things that you would measure, but we're trying to set guidelines on how you could measure things, under which best practices, and how you organize the data if you want to pass them to Darwin Core. There's 2 new ones, those little blue boxes, ocean sound and ocean color are essential ocean variables that are emerging for biology. And we have worked very closely with the GCOS, the Global Climate Observing System, that has now adopted some of the essential ocean variables, some of the biological essential ocean variables to be essential climate variables. And specifically, that's ocean color in plankton, okay? But if you look at this graph, and this is in the latest GCOS implementation plan for the next few years, you also have some terrestrial variables, and I have been wondering why the terrestrial community doesn't use this link better. So GCOS adopted that, but I don't see talk between, for example, GeoBond and the terrestrial community on how to better inform and how to connect EBVs to the ECVs. And ECVs are essentially what the Intergovernmental Panel on Climate Change is using. So it's an important link. So how are these things related? And I've shown this graph several times already. Other people have too, is that this graph of circles was published in the Framework for Ocean Observing that came out that was published in 2012. And it links to the Pereira et al. Framework for the EBVs at the bottom circle, where the raw observations, the individual observations live, and then they get aggregated into basically what is simply time series of biological or biodiversity variables. And that's what is so simple about this. And you can have time series of maps, or time series at a point, time series in one location, or time series globally. They're all essential biodiversity variables, and there's not one that you have to have, or you don't have to have them all being global or all being modeled. So I think that that's the part that causes confusion. It's whatever, like our French counterpart said, it's what you need. You know, if you need it, it doesn't matter if you call it an EBV or not. It's kind of a language that we have adopted to organize our own community. So basically, the ECVs and essential ocean variables really feed into what we would call the essential biodiversity variables. And they showed exactly the same picture. This is another representation of the same thing. This has been published many times, and it's still confusing to the community out there. So with MBON, we have tried to organize the community around the whole world, linking with different projects, having projects in the water, measuring things, linking with other groups that measure things. And so we have a secretariat in the Azores. We have a secretariat under the Asia Pacific BON. And we have one that is emerging in Europe that Mark Costello is leading. Under MBON, we also have a series of working groups that try to deal with some of these things, from data management to remote sensing, eDNA, and so if you're interested in some of these, let me know. We have made a lot of advances now in the technology, so now some measuring things in the water is a lot easier than it used to be 20 years ago, and that is a limitation that is going away. It's still costly, but we need to, so we have optics, eDNA, we have platforms, we have satellites that measure things, and one thing that we still have a lot to work with is data management. And this is one thing that we're working closely with OBIS. It's trying to map the data flows, and I've heard that the data mobilization data flows a lot in this conference, and also then how you visualize the data products, especially the users. They are not interested in complicated platforms. They want a simple thing with a cartoon of a fish or a coral or a tree where you click and the data is updated automatically and they can see the graph. And so most park managers, most protected area people, and even most industry people want to have a simple tool like that. Anyway, so that's the same thing, but with a Spanish accent. Thank you.
Yep, thank you very much, Frank. Nice presentation. Do we have a question? Okay, Hiroyuki.
Thank you very much, Frank, for the this very clear overview of the observation communities and also the programs. I totally understand, clearly understand that. And regarding the terrestrial part that you mentioned in the framework of the GCOS, excuse me, I remember that a few years ago at the Geo Symposium, we had a kind of panel discussion from the GCOS or ILTR or in some other part, because for the terrestrial part in the GCOS, I mean, essential climate variables, there are many challenges, particularly for the sampling points and measurements scheme, or we have the observation gaps already. So there was a discussion that how can the community fill these observation gaps, particularly for the terrestrial part, and the question was who or what organization will try to do that. So this discussion is still ongoing, and I believe that in the very near future, that recently the Geo-Infrastructure Data Task Team was established. So maybe in that framework, particularly for the institute part, this question will be discussed continuously.
Very good. I'm really glad to hear that. Of course, we have the advantage that we have the Global Ocean Observing System at the level of UNESCO that can bridge to another UN agency. But there's other UN agencies, FAO, and there's any number of them that can. But I'm glad that the GCOS community was wondering, well, we can't find people in the terrestrial community to really help us develop these ECVs. And so if that's happening, that's a good.
Until several years ago, there was a GTOS, Global Terrestrial Observing System. Maybe the FAO was trying to contribute that, but maybe I don't know the detail, but the time being, then the activity was depressed. So maybe now the GeoBond would have the great role to fill that gap.
Yes.
Okay, thank you. I think we have to go on. So thanks once more, Frank. And then we have the final talk of these 3 sessions and this topic. So do we have Colleen Royal here? Okay, and you will tell us about from EBV operationalization pilot to GPOs, a French-Bonn point of view. Welcome, floor is yours.
So back to French accent, I guess. So I'm Colline Royot. I'm here to represent the French Bonn on our EBV operationalization pilot to support eventually the Global Biodiversity Observation System. So I think by now everyone has a sense of what are EBVs, so I'm not going to try to give a definition of it. I'm just going to focus in this presentation around 2 of the 3 key characteristics of the EBVs, which are feasibility and convenience. So at the French Bond, we really rely on the EBV workflow concept that has been published by Kissling and collaborators in 2017. So that places EBVs in between observation and indicators. So the main question of this presentation is, of course, how do we propose to operationalize EBVs? So the main response we want to give is to use what already exists. So of course, it's always the easiest to use what existing concepts. So of course, like EBVs, EBV workflows, but also FAIR principles. And then what we already have also is existing data. We have a lot of data. Of course, there is bias. Of course, we need more data. But we can try and use what already exists to produce EBVs. So at the French Bond, we really believe that EBV, we can have fair data through rich metadata, notably by using the ecological metadata language metadata standard, which permits rich description of any kind of data. So here you can see the French Bond data catalog. You have the EML file that permits to describe the raw data and associated derived datasets, so EBV derived datasets, but also indicators and workflows that permitted to compute these indicators. So you have a good provenance, and you have your whole EBV workflow that is traced by your EML file. So speaking about analytical workflows, so we use mostly scripts, so we have many scripts to use. So when you have an existing script, very often, not always of course, but very often we see one script that makes a whole analysis from first modification and corrections to the end indicators. And the idea to get better EBV workflows is to atomize this analytical workflow, so the scripts. So you have one script for each elementary task. So one script for correction, one script to compute maybe one metric, another metric, one script to produce a model, which will permit you to have better clarity and transparency over your workflow. So it's really simple and straightforward advices, but we really think it's the easiest way to do so. So the next thing, the best thing actually, when you have your script that is atomized is to generalize it. So how to do so? For example, very simple advices is to describe inputs and outputs at the beginning of the script, define clearly the changing parameters, so that can be the number of randomization you want in your model, that can be simply the name of the column of your interest variable, and so on. So we have also to define dependencies of these scripts, so packages, softwares, and versions of these packages and softwares, because we have to make sure the same process and the same task is applied. So what will all this help? It will help you go through the workflow approach, so which will permit you to reuse and adapt, even locally for your own use, all your processes. So of course, as we are talking about EBVs, the purpose is to share it openly and to share it with colleagues and inside a national bond or in the whole network. But maybe one day you'll need to make only corrections to compute your metric and make your model. Maybe the other day you want to compute another metric that will need formatting, but the same corrections are needed. It will really give you plasticity over your workflow and your analysis. So at the French Bond, we're using the Galaxy platform. So I'm not going to go too much over it, but it's a web platform that permits you to use script
through an interface, so it can be an R or Python script or any other language. So it makes it easier to use for other users or for your students or etc. And so it's the same thing as I just said about workflow approach with scripts, but it's easier on Galaxy as each elementary task is a tool. It's usable through an interface. You can have full visibility over your whole workflow on Galaxy, see all the steps that your data is going through, etc., etc. So what I just presented you is really the simple thing we used to build the basis for the French bond. So hoping this presentation will maybe help, maybe give motivation for other national bonds to build, and hopefully to have finally a global biodiversity observing system. So to conclude, the major motto is to rely on what already exists and has proven efficiency, such as concepts and principles to adapt and apply to help identify gaps and bias in the data we have. Then existing data that we have to use and reuse to exploit full potential. Also analytical processes that need atomization and generalization to get plasticity and reproducibility. And finally, technical solutions and related networks, such as Galaxy, for example, but it can be anything else, Data One also for data, that need to be shared and needs contribution also to enhance communication and networks. So what I just presented you is part of the EBV Open Science Cloud case study on which we built the French bond. So to, as I said, maybe build the global biodiversity observing system and also support bond in a box. I see Andy very happy in the back. So thank you very much. I'm not sure I can answer all your questions because of course, many people is working on this. I don't have all the answers. But we are 3 members of the French bond at the conference, Yvan Lebras, that is just here, Olivier Norvez there, and myself, Connie Royaux. So please come talk to us if I don't have the answer you're looking for. Thank you.
Okay, thank you very much, Colleen, for this presentation. We might have time for quick questions before the final conclusion session is starting here. Okay, Hiroyuki.
Thank you very much for your proposal and a good idea for that. And just one quick question. Could you please let me know again why you choose the EML for the metadata-based language for your system?
It's because it permits very good description of data, of ecological data especially, so it's really good for EBVs. And as I said, it permits to have the provenance of each EBV product you are producing if at the end we are using it for the production of EBVs.
Yeah, thank you very much. I ask this because that many LTR networks in the world, I mean, maybe you know the International Long-Term Ecological Research Network, and we have the 44 national LTR networks in the world. And many of these networks use the EML also for their metadata base. So I thought that if your system use the EML, and that could be a kind of, could generate some synergy or connecting point with the LTR community for the further networking.
Yes, of course, yeah.
Oh, okay, yeah, there's one question. The comment.
Just link to that, because in fact, maybe we don't speak about coding, but if we choose the EML at the origin, it was because it was used by LTR, because in fact, LTR is maybe the best case where you need to track in a fine grain in the space and in the geographical coverage data for a long term. And we are saying, see, if LTA are all converging on this, it's because there is a reason, and that's why we started with these amazing standards. Yeah.
Okay, I thank you. Hello. Okay, so thanks for these questions. Thanks once more. And I see we are getting a lot of audience, so the rumor has gone through that there's a best session going on, so I think it's time to wrap up. I will give floor for Hiroyuki. On my own behalf, I already would like to thank all my colleagues, so Hiroyuki, Guillaume, and all the great presentations today, so thanks everybody, and also the proud audience who was able to stay here until the Friday afternoon. So thank you everybody. And Hiroyuki, floor is yours.
Okay. So just to wrap up quickly, so people are getting back here, welcome. And then I'd like to just give a very quick wrap up of this linking networking session. So this is just an agenda for this our session today. So this is the overview of what we discussed, what we found today, and what would be the points that we need further considerations or designing. For example, if we think about network of the scientists or community of practices or network of many kinds of bonds, or we might think about the networking with other Earth observation communities like ILTR and FlaxNet and others to think about the GBIOS concept or to pursue the interdisciplinary research observations. So also we learned many observation domain, terrestrial, coast, marine, and freshwater. But we also need to think about some infrastructures, inch plots, eDNA, UAV, sensors, and satellites. A network is also important for capacity development for observations, samplings, data mobilization, and use of knowledge and information. One more point that we need to think about for the capacity development, facilitators. This is not only the translators, but we need a kind of people that understand well both the science and societal challenges. Then this facilitator would bridge the science and social stakeholders. Finally, the engagement, academic and individual scientist groups, citizen sciences, stakeholders, and what we didn't much discuss today is that network would work to engage the communities from the unprecedented countries or region. Today, we learned from Mark Grant's presentation and also from others that network could have a very important role to reach out to the small countries or some unprecedented regions. So the geo-bond, regional bonds, and national bonds or thematic bonds would have that kind of important roles. And finally, finally, we discussed also about the essential biodiversity variables as our common language or guidelines for the observation and data mobilizations, and bond in the box as a tool for our further cooperation. Then let's try to share this question again. Maybe we can ask ourselves about the questions related to the networks, and maybe in the future, if you want to engage some other people or research groups, community of practices to network with us, maybe they ask these kind of questions. Then let's just prepare for the answers and have our networks more broader and also deeper. Thank you very much for your cooperation, and also please give your big hands to all the speakers. Thank you.